Welcome back, everyone. We are here for day 3 of our completely free AWS Certified Solution Architect 2023 course. It's to help you prepare for the AWS Solution Architect certification, and it's an AWS full course tutorial. This is free AWS certification training. The reason we run this free AWS course to prepare you for the SAA-C03 exam is because we want you to have the skills to understand the technology. What is it? How does the technology work? Why should an organization use this? And we are producing this course biased to the architect. Because for the architect, it's not about clicking a bunch of buttons, configuring things. For the architect, it's about understanding our client's business problems and then determining what technologies will help them achieve better business performance. And all these technologies we're really talking about are networking and data center technologies. And that's all the cloud really is somebody else's network and somebody else's data center. Kind of like a hotel where you were in a room in the hotel. That's what cloud computing is. Somebody else builds a giant data center and you rent space. So we're covering this from the architect perspective. Now, I want to tell you about some free things we're going to give you before we begin, and then we'll get into the content. If you haven't attended one of our How to Get Your First Cloud Architect Job webinars, sign up for Monday's webinar. Today we had an incredible webinar. All over the world, people came, and it was an experience. But guess what? We're going to hold another one on Monday night. My team is going to drop the link for you to sign up for this. I encourage you to sign up for this. Certification is 3 to 5% of what you need for that first cloud architect or solution architect job. And on that webinar, we'll talk about the entire 100% so you can develop the right skills to get anything you need. If you missed today's webinar, we're going to hold another one on Monday. So please sign up for that. While we're at it, we wrote a completely free ebook for you on all the things you need to know to be a great cloud architect. Download that too. It's free. And between this free e-guide and this free webinar, you're going to know everything that you need to learn. And the cloud architect job and the solution architect job is not what 99% of the people think. It saddens me. I've interviewed thousands of AWS certified people, and they studied everything other than cloud architecture. So I want you to know how to get this job. And that's why we're covering it in depth of more what is the tech and how does it work. Because for the architect, it's about us putting the pieces and parts together. We don't configure it. That's what cloud engineers do and DevOps engineers do. And they're wonderful. We need everybody. We design it. Somebody else builds it. The same way a building architect designs the hotel or the shopping mall and a construction crew builds it. We cloud architects design it, present it, sell it to the clients. And then those team of amazing genius engineers, cloud engineers, DevOps engineers, they go and deploy it for us. So that's why we're doing things the way we are today, to assist you in the cloud architect community, because our channel is focused for cloud architects. So I also want you to get the completely free AWS exam guide. Our team wrote a completely comprehensive book for you. It's completely free, about 500-600 pages of content to help you pass the AWS Certified Solution Architect Associate and Professional exam. And what's the difference between the two? The depth. So we went good and deep on that book to give you the skills that you need. So download the free book, completely free. So getting back into our AWS content, if you'll, and actually before we do that, give me a hashtag. I want to know you're awake. I want to know you're alert. I want to know that you're oriented and that you're here and you're ready to learn. So give me a hashtag that says hashtag SAA-C03, hashtag Sierra Alpha Alpha Charlie 03. So when I see that's coming in, at hashtag SAA-C03. Fantastic. I see you're here. I see people all over. And when you're done that, tell me in the chat box where you're coming in from. I'm in Port St. Lucie, Florida today. And we're at it. And also, you know, when you put together a live production like this and you take 10 people from my staff, all the gear, it costs as much as buying, say, a Kia brand new. So please share this with others. I want to make sure other people take advantage of this free AWS training. That's why we do it, to help those in need. So please share it with somebody else. Give you a second, send a tweet, send an email, send a text, send a link, invite people to train. That's why we do it completely for free. Love all these SAA-C03s popping up. Where we got that is that's actually the test number from Amazon for this exam. So thrilled to see all these SAA-C03s, otherwise known as the AWS Certified Solution Architect Associate Exam. Okay, so now we're going to get back into the content. And if you'll recall, yesterday we started to talk about the VPC, or the Virtual Private Cloud, which I like to refer to as your Virtual Private Data Center. And we're going to continue this, and we're going to talk about something called placement groups. And let's talk a little bit about it. So anytime we're dealing with networking, the farther the things are away from each other, the higher the latency. And here's the reason why. When we're dealing with a fiber optic cable, we're dealing with sending a photon or some light across the cable. Now, the speed of light travels at 186,000 miles per second. So that's pretty darn fast. But there's still latency between you and the location. So I want you to keep that in the back of your mind. Latency. The closer you put your stuff together, the better the performance. The further your stuff is away from each other, the worse their performance. So kind of keep that in the back of your mind. So when we talk about placement groups, it's about improving performance by either bringing stuff closer together or further apart. So a placement group is basically a logical grouping of where you put your virtual machines. And the closer they are together, the better their performance. Now, I want you to think about it. The closer you put your machines together, let's say if you were to put them all in the same rack, which is going to give you very fast performance, if the power goes out for that rack, you got nothing. You're done. You're out, which is kind of a disaster. So kind of keep that in the back of your mind. The further you spread it out, the more distributed, guess what? Poof. The more reliability you have, but at the same time, the lower your performance is. So which should you choose? The one that's right for your customer's business needs. That's the one you choose. So placement groups are logical groupings. In most cases, a placement group is inside of a single data center or availability zone. And the closer they are, the lower your latency. You get higher packet per second performance, higher network throughput. And placement groups are going to be used when you want to build high performance computing clusters, or at least the highest performance computing clusters you can do on the cloud. So that's why we're talking about it. Now, the first thing I'm going to talk about is going to be the highest performance you can do, and it's called the clustered placement group. And this is where we put our stuff really close to each other. So typically with a clustered placement group, all of our servers are all sitting in the same rack. Sometimes their virtual machines are all on the same physical server. And in order to route between them or switch between them, we don't even have to go to the switch. It's all done directly on the server itself. So very low latency. Well, pop all your stuff in a single physical server, and that server crashes, like a hardware crash, the whole thing goes down. Have it in a rack and the power distribution unit for the rack goes down, or both of them go down, like with the circuit breaker blowing, you can lose them all too. So cluster placement group, really good performance, very low availability. Here's what it's going to look like from an architecture perspective. If you want to look at it, you think your stuff is all in a single rack, very low latency, very high performance, but lose that rack and you are in trouble. So everything is a trade-off in architecture. Then again, everything is a trade-off in life. You can have your money, you can spend it on buy something, you can have calories, you can eat a cookie and take in too many calories, or you can eat broccoli and not take in too many calories. The choice is yours, but we all have to think about it. Same thing in architecture. Now let's talk about a different kind of placement group. We're going to talk about a partition placement group. Now with a partition placement group, we're going to spread them out a little further. Typically speaking, we don't want everything in the same rack unless we need that performance, because if the rack fails, you lose everything. So with a partition placement group, we're going to spread stuff out a little farther from each other. And it's going to give us relatively good performance, with relatively low risk and less single points of failure. Let's face it, if you're in a single data center, it's a single point of failure, but it's reduced single points of failure. And here's what it typically looks like. It typically looks like you've got a couple of racks inside of the data center or availability zone. And this is typically what we're talking about. Now, again, you're still in a single data center, which is a problem. But if you wanted to spread it among 2 data centers, well, that's what a spread placement group is for. And in a spread placement group, we place our virtual machines and our stuff across even more distributed hardware. We may have our racks and our physical servers, our power distribution units may be in 1 availability zone, maybe 2. And by doing so, we're going to have a lot greater latency than we would if it was together, but we have higher availability, less single points of failure. So architecturally, here's what a spread placement group is going to look like. You've got 2 data centers, and you can sit by availability zones, and the equipment is spread across racks. This is going to give you a degree of higher availability than you would have otherwise. So let's talk about getting more network performance that we can have. For those of you that are new to computing, understand that we have hardware-based things and software-based things. Hardware is fast, fast, fast. Software is slow, slow, slow. Which is why if you build the server in your data center and you don't use a hypervisor and it's bare metal, it's going to perform better than a virtual machine, but a virtual machine will be more agile. Now, what do we do in technology when we need high performance in a virtual machine? Well, there's 2 options in virtualization. We can use software-based virtualization. And if any of you have ever run a virtual machine on your computer, like you're a Mac and you run Windows and you notice that you can't play games very well on that virtual machine because your graphics performance is horrible, well, that's because you're using a software-based graphics processor versus a hardware-based graphics processor. Well, same thing happens with networking. When we're dealing with virtual machines, we can either have a physical network card, like a 100 gig card that you might, gig Ethernet, that you might have in a server, or we can have the software-based cards that you're going to get from your hypervisor. Well, if you need really good network performance, you can actually push a piece of hardware, physical hardware, in your virtual machine. And it uses a technology called PCI pass-through, where you're taking something that's plugged into a PCI port on the server and you're passing it through into the virtual machine itself, which is great. I use it all the time. Now, there is a name for this when it comes to network cards, and it is called Single Root I/O Virtualization, otherwise known as SR-IOV. Ridiculous name for something that says, stick a physical network card in your virtual machine. That's all it is. But whether you're using VMware, whether you're using AWS, whether you're using Google Cloud, they all have some form of single root I/O virtualization for high-speed networking if you need it. Now, of course, if you don't want to go physical card, AWS also created a very high-performance software driver for a virtual Ethernet card, and they call that the Virtual Fabric Adapter, and that's got some very high performance as well. It's been designed for up to 400 gigabit a second, but it's not there yet. So now we talked about cluster placement groups. We talked about improving network I/O performance by hardware cards or special software drivers. So now we're going to get into DNS and Route 53. And I'm going to get into the AWS implementation. I'm going to talk about DNS, but let's talk about an architectural perspective. For one thing, imagine you have the AWS cloud, the Azure cloud, and the Google cloud. And you rely on AWS's DNS. And AWS has a catastrophic failure. Do you know what's going to go down? Traffic to your Google cloud, your Azure cloud, and your AWS cloud. So if we're creating a high-performance multi-cloud environment, we may choose not to use AWS DNS service, otherwise known as Route 53, and we may want to use a more industrial DNS service that we can get from, say, F5, that will make multi-cloud wonderful DNS services available for us. So for me, because people come to me with billion-dollar architectures where seconds of downtime cost millions of dollars, I can't afford to use Route 53 or AWS DNS. I have to use a generic DNS service that works across clouds. So if you're multi-cloud, you may not want to be thinking about DNS from AWS. You may be thinking of a more industrial DNS solution. Still, the AWS DNS service is exceptionally good, but we're talking about multi-cloud architecture, which is what 98% of organizations use, versus AWS solutions architecture, which is you only give AWS stuff and everything's great until the cloud goes down. Or you only have access to AWS services and you can't leverage all the best technologies that are there from everybody else. Choice is yours architecturally. So what is DNS, or the domain name system? Well, see, here's the thing. Every device on the internet needs an IP address. But can you remember the IP address? In fact, let me do a quick lookup for you. Which is going to be easier for you to remember. The name Amazon.com, or let me actually find their actual IP address for you. Which is easier for you to remember, Amazon.com or 13.226.54.3. Well, personally, I can remember Amazon.com, 13.226.54.3, which is the local CloudFront distribution in my zip code. Pretty hard for me to remember, but I can remember Amazon.com, and I bet all of you can too. Now, guess what? I checked the next IP address from Amazon, and they're using the Akamai content delivery network. And now their address is 184.84.138.101. Oh my God, how am I going to remember I can reach Amazon on 13.226.54.3 or via 184.84.138.101? I can't remember that, but I can remember Amazon.com. So that's why we have the domain name system, to take something easy and map it to something else. No different than in your cell phone, you have like your wife's number by her name, maybe your friends' buddies' numbers by their name, but you don't have to remember their phone number anymore. You click their name. Same thing that we're talking about. So DNS only maps a name to an IP address, and that is it. So what's it going to look like? So here, you're at your computer. This is the way all this works. You want to go to a website and you type www.amazon.com. Okay. Your computer sends a DNS lookup to find the IP address, and then your computer connects to the IP address. Now, there's a lot of cool stuff that goes down. If you guys want, we can talk about that on another day, from the time that occurs, step by step by step. But the point is, that's all we're really talking about. And DNS simply maps a name to an IP address. So here we do an IP address lookup of GoCloud Careers, www.gocloudcareers.com, and you can note the two IP addresses that we have for our website. Why do you see two IP addresses? Because we have two servers in case a server fails. You'd never want to be in an environment where you've got a single server, because that's a single point of failure. So let's talk about the domain names and how they work. Domain names are going to be broken down into three separate sections. We're going to have the host name, which is going to give you the name of the endpoint. We're going to have the name, the domain name, and then we'll have the top level domain. So I'll give you an example. www.gocloudcareers.com. The www in this case is the host name. GoCloudCareers is the domain name, and .com is the top level domain. Could be .org, could be .net, could be whatever, .co, .uk, .gr. Can be all kinds of top level domains. So that's what we're talking about. It could also be MikeEC2.gocloudcareers.com, where MikeEC2 would be the host name. And those are the things that when they get together, they're called a fully qualified domain name, because you can reach it. Now, how do we maintain this? Well, if we have servers out there that are mapping a name to an IP address, servers have to get their information. They got to store it somewhere, right? So DNS servers are going to have something called DNS records. You may also hear them referred to as zone files. And they're basically just a particular set of instructions for your domain name servers. And the records are going to be in a particular format. You know, anything, we got a particular format. And the format's going to be known as DNS syntax, which is basically a text file. There will also be given something called the time to live, which is how long the record will last before it refreshes itself. The longer the time to live, the less work on your DNS servers. The shorter the time to live, the faster you make a change, and it's going to be propagated to the rest of the world. Again, architectural choice, which is better for you. More work on your DNS servers or more frequent response changes. Now, there's going to be a massive list of DNS records, but we're going to talk about the most basic types of DNS records today. But before we do, let's discuss a few things. So if we're going to deal with AWS, they actually have something called Route 53, which is the Amazon managed DNS service. Again, that's great if only you're going to use as Amazon. But if you want to use 2 and 3 clouds, you better have something a little higher level, because if Amazon's managing your DNS and then Amazon goes down, no traffic's going to be sent to your other clouds, which is kind of a disaster. So would be a single point of failure in your high availability systems, and we can't have single points of failure. Now, Route 53 uses something called Anycast. It's a pretty big discussion of what Anycast is, but understand, if I call both of these, let's say we used Google's DNS servers, which are 8.8.8.8. If I got an 8.8.8 over here and an 8.8 over here, what happens is you, by routing, will go to the closest 8.8.8 that you have. If this DNS server dies, you'll still be able to reach 8.8.8.8 because that's what your systems are configured to reach. So AWS does use a good, highly scalable, highly available Anycast service, which honestly is relatively low latency, very high availability, and supports health check. It's a great DNS service, but in multi-cloud, you want to do your own instead of creating a single point of failure. Now, when we talk about records, there's a couple kinds of records we really want to talk about when we discuss DNS. And basically, they are what's called an A record. Could be a test question, so I'd remember it. An A record is simply mapping a name to an IP address. Real simple, just like I showed you for Go Cloud Careers. That works great for IPv4, but what if we have IPv6? Well, now we turn the A record into an A record. And it's the same record that we have, but it's an IPv6 record. Then we might have something called a CNAME record. So when I started this company, we were Go Cloud architects. And now we train business leaders, tech leaders, and the such. We also have some other architect programs in development, and we changed it to Go Cloud Careers. So what happened to all the people that used to go to Go Cloud Architects that when we wanted to go to Go Cloud Careers? We created a CNAME record, which basically maps the domain to another name, similar to an alias record, but slightly different. Now, what if you want to receive email? If you want to receive email in a domain, you're going to have to create an MX record. So those are kind of your biggest key name records that you want. There are many other DNS record types that you possibly should know in your career, but they're the main ones that you're likely to see on an exam. So keep that in the back of your mind. Probably should always talk about the SOA record as well, which is the start of authority record. And that really will tell you who is the primary name server for your domain, the people that are responsible for your domain, meaning the responsible party. It will give you timestamps of when anything else is going there. And that's really the key. So I see the questions popping up as I'm talking about it, so it's there. If we put F5 DNS servers in 3 different clouds, it's not a single point of failure because we have 3 sets of servers and 3 sets of data centers. It's only a single point of failure when we only have one domain, like just Google's DNS or just Amazon's DNS to manage it. So by going to a more industrial solution, we can not only more particular with our DNS policies, we can create higher availability solutions with less single points of failure. And we can also, not that I would suggest it, we could actually leverage, if we wanted to, Route 53 to do our data center and our cloud. But again, what's the point of having a data center and a cloud if the cloud goes down if your data center doesn't stay up? So, think about that. Now, with DNS, we're going to have all kinds of policies. And, the policies that we're talking about are how you want your traffic to be routed or routed. And we're going to cover simple routing, weighted routing, latency-based routing, failover routing, geolocation routing. multi-value answer routing, and geo-proximity routing. Simple routing is quite simply, we take the name, we map it to a DNS address. So that's it, simple routing. Here's I want to go to www.gocloudcareers.com and I send all the data just to the single Go Cloud Career service. One web server, simple routing is beautiful. Map name to an IP address and that's it. But it's not going to work everywhere. But simple routing would typically map you to the load balancer's external IP address, and we'll get into load balancers. What about weighted routing? Weighted routing is very kind of routing, and there's good kind of routing, and there's a million uses for it. Weighted routing is where you tell DNS how and where to send your traffic. Using AWS and Azure, send 50% to AWS and 50% to Azure, and if either one goes down, send the rest to the remaining provider. Done. Beautiful. But where else might we use weighted routing? Let's talk about blue-green deployments and other types of rolling out new applications. Do you think a business that does, say, $10 million of e-commerce sales is going to put up a new website and re-architect it and let their business go bankrupt because of all the bugs they're going to get? Of course not. But we may have a system that we want to migrate, 5 years in the future to something else, and we could create a new website. And we could shift 10% of the traffic to the new website, see how it works, and keep 90% on the old legacy product. And as we get more comfortable, direct more and more traffic to the new website and pull back the old website until we know that the new website's perfect. We're constantly doing this with new applications. We send 90% to the old and test it and 10% to the new. If it all works, we can shift it all over the new. It's a great way to deploy applications, and weighted routing is there. So share to multiple clouds, share to multiple data centers, or deploy new applications. Weighted routing is beautiful for this. And really, architecturally, what does this look like? It looks like this. We can have one load balancer with our stable systems, another load balancer with our experimental new site, and assuming it works, we are good to go. So we've covered simple routing and weighted routing. What about latency-based routing? Well, here's the thing. Nobody likes going to a website and waiting for it, and waiting for it, and waiting for it. And guess what search engines don't like? Websites that take a long time to load. They penalize you for search engines. So latency-based routing is going to enable you to send your traffic to where it has the lowest latency possible, offering your customers the best performance ever. For example, you could have web applications hosted in London and also hosted in Tokyo. And if your client is in Australia, their IP address is going to be determined. It'll say what's the latency to go to London versus Tokyo, and that website's traffic would be routed to Tokyo. By comparison, I've got a user in Spain. It picks up their Spanish IP address and it sends them to the website in the UK. That is latency-based routing. It is used all over the world. It is phenomenal. You can think about it this way. Here we've got a request, and we send it to the appropriate people. What we got. Should be fairly simple for you. Now let's talk about failover routing. I use this stuff all the time. Let's say that you have your data center up and running, and you want to send all your traffic to your data center. But you've created a backup policy where you've got small instances running on a cloud provider, and if your systems go down, you want all your traffic to go over to the cloud provider, and then auto scaling will take the cloud provider up. 45 minutes later, you've got a fully running operational site. That's failover routing. Failover routing could also have AWS and Azure. And if AWS goes down, send all the traffic to Azure until AWS is back up. It's failover routing. Keep all your stuff in AWS. Have a small version of it in Google. AWS crashes and burns and goes down for 4 hours. Google takes over. Again, failover routing. And we could do any of these architectures. We could get it down to minutes, that failover, if we chose to, based on how we set it up. So failover routing, fairly simple. You got your primary, and if it's marked unhealthy, and we'll talk about that, then we get our secondary. All this is to keep our systems up and running. Now, the next one is geolocation routing. And this is sending you to the website that is closest geographically to you. Now, geolocation routing is really great. Let's say, for example, you're in Europe and you're in Greece, you get sent to a Greek website. If you're in Turkey, you get sent to a Turkish website. What if you're on an island, Cyprus, which is half Greek and half Turkey? Wouldn't it be great if you're on the Turkish side to be sent a website in Turkish in the language that you speak? And if you're in the Greek side, to be sent a website in Greece? All in the same country? Well, do we know countries in the world where people speak multiple languages? Yeah, we do. Are there countries where we have people of multiple cultures in the same country? Sure, we do. And wouldn't it be great to send people to the right language website? And we can do all that with geolocation routing. We can find somebody where somebody is. That's really what we're talking about. Keep that in the back of your mind. Cyprus is a beautiful place. I'm more familiar with the Greek side, to be fair. But, my family also lived in Turkey for a period of time, too. So, either side, we're pretty happy. Wonderful place, people on both sides of it. So the next thing we're going to talk about is multi-value answer routing policy. And here you got multiple options. And we just randomly say, here you go. Here, go to this website, go to this version, go to this one. Look, there's nothing wrong with multi-value, but I don't like rolling the dice and figuring out where my traffic's going to be. I want to know where my traffic's going to be. And multi-value is just at random. And pretty much all DNS providers have those. Geo-proximity is going to send it to your geographic area. This is an AWS concept, and it uses the concept called bias. Basically, we've got this geo-proximity map, and you see how we have these regions A, 1, 2, 3, 4, 5. We can use something called bias to shrink those regions or expand those regions to try and guide our traffic where we want it to be. That's geo-proximity routing. I've never used it in my life, but AWS does support it. Now, how does DNS know if your stuff's available to be sending your traffic to? It does something called the health check. Now, if any of you guys come from a networking background, you know how we send hello message to the other routers to determine if they're there? A health check does the same thing. And here's how a health check typically works. And whether it's a load balancer health check, a routing health check, a DNS health check, it's pretty much the same. Here we've got two servers. We send a message to the server. Are you there? It says, yes, I'm here. All's good, right? Send a message to the server. Are you there? Yes, I'm here. We keep sending messages to that server. Server, are you there? Guess what? It works. Now, you see we have two servers. Now on the bottom server, server 2, are you there? No response. Server 2, are you there? No response. Server 2, are you there? No response. DNS now knows to send all traffic to the first server. That's what a health check does. It determines if you're there. If you're not there, it marks you as unhealthy, and it doesn't send you any more traffic, because we don't want to send traffic to dead servers or dead data centers. So before we get into load balancers, let's pause here. Let's see if we have any questions, Chris. If you build a private server at home, how can you access it from a different location that's not home? Well, first, you have to have direct IP connectivity to your server, meaning if it's behind a firewall or behind NAT, you're not going to be able to reach it. Now, depending upon your environment, you may be able to port forward certain IP ports to your servers. For example, you could take your external IP address and then forward certain ports like port 443 to your web server, if your service provider will allow it. Now, you're also going to need to know your IP address. And also, if you build the server at home, you have to make sure that it's serving, you've set up the permissions. But, doing that at home is relatively easy. Now, would you do that or should you do that? I wouldn't. I would do the following. If I had a server at home, and I have servers at home, I would actually take my firewall, I would create a demilitarized zone. And in that demilitarized zone, I would put the things that I want to be reachable from the public internet. I would close down all ports to that, and I would place my server in the demilitarized zone. And I would consider that a high-risk server. I would put a host-based firewall on that server, open the appropriate ports. I would remove all the unnecessary services on that ports. I'd put some host-based IDS IPS systems talking to the IDS IPS systems. I'd be leveraging, in addition to firewall rules, I'd be putting some access control list rules. And there's a lot to do this. Now, setting up demilitarized zones to do this properly is honestly a 30 to a 60-hour conversation. It's not something that you can get in a simple chat GPT answer, or it's not something that's very simple to describe there. This is remote access, and this takes serious networking and security knowledge. And the kind of server that you need will determine what you need to do, but that's essentially how you would do it. Chris, let's go to the next one. Are health checks done on HTTP? Oh, health checks generally, there's multiple kind of health checks. Sometimes they can be done via TCP, sometimes they can be done via UDP, and sometimes they are done via ICMP. Sometimes health checks are done in a routing protocol like OSPF. So the application will determine what the health check is. Isn't geolocation and latency the same? No. Latency is the latency to get to something. Geolocation has to do with geographically where you're at. We'll go to the next one, Chris. Based on GeoDNS, are there ways to choose which traffic should be filtered or routed, like selecting countries that should be directed? Geolocation or geoproximity, which one? I don't know what you mean by GeoDNS, and they're both different. Geoproximity basically looks at your source IP address and takes you to the source that's closest to you. So it's not about which traffic should be filtered, but there are ways that you could set up a DNS policy where certain people should be spent to where. Chris, let's go to the next one. Minesh Kumar, will Route 53 work in a multi-cloud architecture? Sure, if you don't mind creating a single point of failure. It'll also work in a hybrid cloud architecture if you don't create a single point of failure. So let's say you've got 3 clouds, and all of your DNS is handled by AWS Route 53, and AWS goes down. None of your traffic is going to go to Azure or Google because it can't. So if you architect a multi-cloud or hybrid cloud environment by using Route 53, expect that when Amazon goes down, all of your other clouds will also go down, and you've got nothing. So if you're going to do multi-cloud architecture, don't use anybody's managed DNS. Go to F5, get some virtual DNS servers, which are going to have much greater features and functionalities anyway, and then you'll pop them in each data center. And that way, when any data center goes down, you won't care, or any cloud goes down. So you could do it. Look, you could do anything, Minesh. You could blindfold yourself, get in a car, and drive drunk. The question is, should you? And the key is, if you've got multi-clouds and you put all your DNS in a single basket, you effectively removed all the benefits of the multi-cloud architecture. So I wouldn't. But architectures are a set of trade-offs. You can choose any trade-off you want. It's quite a good question, actually. Okay, so we're going to get back to the content. Please, if you haven't subscribed to our channel, please do so. If you haven't liked the video, please do so to signal YouTube to send it to more people. We work hard to provide quality free content. And while you're at it, leave a like, subscribe, hit the bell, be notified. We got lots of cool stuff coming your way. So now we're going to talk about load balancers. Now, of course, if we're dealing with AWS branded anything, they're going to call it an elastic load balancer. And we're going to talk about load balancers in general, because whether it's an Azure load balancer, an AWS EC2 an AWS load balancer, Google Cloud load balancer, an F5 load balancer, it's the same stuff for the most part for the last 30 years. Load balancers are one of my favorite devices in the entire world. Why? Load balancers improve performance and they reduce single points of failure. I'm going to say it again. Load balancers improve performance and reverse single points of failure. If I can use a load balancer, which is a high availability device, to load share across 6 servers, and one of those servers goes away, I still have 5 more. That's my high availability. But guess what? What if the load balancer were to crash? Well, when we're dealing with cloud-based load balancers that aren't real, they're software-based and they can be on 15,000 servers all at the same time, so they never crash. So a logical load balancer from your cloud providers will need, you don't have to worry about crashing. In the data center, we're going to use multiple sets of load balancers. And if we need load balancing functions that's bigger and better than the AWS load balancers, and we go to the AWS marketplace to get something from F5, and many businesses do, then we need to use an AWS load balancer to load balance between our software-based load balancer. But that's advanced architecture way beyond what we're talking about here. So a load balancer is a device, software or hardware or both, that will take traffic and distribute it to multiple places. And load balancers enhance scalability. Why? I've got a website that needs 1,000 servers. I use a bunch of load balancers and it shares across the servers. So lots more performance, and of course, remove single points of failure by splitting the load across servers. One server dies, who cares? You could have 1,000 others, no big deal. So how do load balancers do their load sharing? Well, very simply, they run health checks to determine what's there, and they run an algorithm. And they can share one by one. They can do it based on latency. They can do algorithms like round robin, weighted round robin, and other types of things, but way beyond this kind of course. I could spend 2 months talking about load balancer architectures. I'd love to. And hence the difference between an architect and a certification. So when we deal with load balancers, they really are two categories, regardless of what they're named. They're basically either network load balancers or application load balancers. And a network load balancer operates at layer 4 of the OSI model, and it's typically looking at the source and destination IP address and the TCP port number or UDP port number or on the protocol number. That's it. Or we're dealing with application load balancers that are very, very smart. And when we're dealing with smart application load balancers, we're going to be looking deeply into the header. We'll talk about that a little more. And because the application load balancers do a lot of intelligence, they're slow. Because network load balancers don't do a lot, they're fast. Well, give you an example. 2 plus 2 plus 2 plus 2 plus 2. How fast can you do that? 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. Think of that as a network load balancer. Now, for the application load balancer, 437 by 12 plus 236 plus 12 plus 4,396 divided by 0.03. Add that up and do that fast. Well, you see, the one you can do in your head and the other you've got to calculate. The more calculations these devices has to deal with, the more you actually have. So our load balancer choice is going to be based upon our needs. High performance, network load balancer. Network devices like firewalls, network load balancer. Microservices, low performance, typically speaking, we're typically dealing with application load balancers, but not always. So a load balancer, what it's going to do, it's going to take the incoming traffic and it's going to distribute it to, they call targets. Boom, boom, boom. So it's sending the messages, fast as it can to different locations. So AWS load balancers are auto-scaling, meaning, they're going to add capacity as needed. Kind of think of it that way. If they auto-scale, think they're going to use more IP addresses. So when you do your IP addressing, leave yourself some space. Here's a cheat. Wide area network links in the rest of the world use a /30. LAN links, where you put your servers, typically a /24. You can't use a /30 on AWS because of the funny way they deal with IP addressing. So the shortest you can use is a /28. But kind of think about that. Load balancers can load balance your traffic across availability zones. Your load balancers can also terminate your SSL connections. I want you to think about how awesome this is. So when you want to connect to a web server via HTTPS, you're actually encrypting your data. Now, when you encrypt your data, it takes a lot of mathematical computations to encrypt your data. And all of those SSL termination and encryptions place a lot of load on the web server. If you can free up your web servers to just serve stuff and not deal with encryption, they can do a lot more work, which is great. So you'll need less of them. If they're busy doing encryption, you got to do a lot more of them. Now, the load balancers from AWS can actually terminate the SSL, meaning all the encryption can be done on a load balancer. So we're further reducing the load on your servers so you can use smaller servers and less expensive servers. Now, do you see why I love load balancers? They improve performance, they reduce server overload, they improve availability. Pretty much I use load balancers everywhere. It's one of those things, load balancer here, load balancer there, load balancer everywhere. So when we talk about AWS, we're going to talk about an elastic load balancer. It's just a load balancer with the name elastic on it. We're going to talk about a network load balancer, and AWS network load balancers route traffic based upon destination port, TCP protocol, and port number. That's it. And network load balancers are very fast. They can handle millions of requests per second. They're great with rapidly changing traffic patterns, and by the way they work, they are stateful, which means if we are taking a connection from source IP address 10.1.2.3.4, source port 236, to a destination of 192.168.1.1, destination port 4483, that flow gets placed into the load balancer. That load balancer places into a table, and the connection is going to be stateful. The entire time you're on that session, it's going to send it poof straight to the same server. So this is really great. And with a load balancer, a network load balancer, you put a static IP address on it. You can route to containers. You put a static IP address on anything like this. Now, what does it look like for those of you that are unfamiliar with load balancers? Here, basically, you've got a network load balancer. It's load balancing between two availability zones. And what do you call it? You've got the load balancer balancing between two sets of servers in two different data centers. Now let's talk about application load balancers, okay? Application load balancers work on layer 7. So instead of like being a network load balancer, where so it's TCP or UDP, port number, and source and destination IP address, now we're getting really geeky with our application load balancers. We may be looking at the path in the URL. We may be looking at elements like the HTTP or HTTPS header. We may be looking at HTTP method-based routing, things like push or get. We can route you based on your source address. Billy Bob goes to this server. Jimmy goes to this server. Al goes to this server. You can do that too, because they're very intelligent. But at that intelligence comes a penalty in terms of speed. So when would you use an application load balancer? When you've got very small servers, when you want to load balance HTTP or HTTPS traffic, when you want to balance requests from microservices and container-based applications, if that's appropriate for the organization, to load balance multiple requests on the same virtual machine on different ports, and they can load balance between your VPC, your on-premise data center, and the set. But realize these are slow. So it's probably going to be a little faster to use a network load balancer to balance between your VPC and your data center. And the way this works, we're going to have our load balancer, and it's going to send it to a group of targets, which are servers. Now, I could tell my load balancer, send it to server 192.168.1.1, 1.2, 1.3, and I could put these manual entries and different specifics for each server. Or I could create what's called the target group and says all Cindy the Cat web servers, and force everything to just the Cindy the Cat web server. And that's really what we're talking about. So Amazon also has something called the classic load balancer. Guess what? It's the same thing, but it's an older version and they don't want you to use it. So you move to the newer ones. It's basically the same as everything else. You've got a network load balancer and you've got an application load balancer, but the classic load balancer is an old version and they recommend you use the new version. So let's talk a little bit more about load balancers and the architectures. We're going to have two kinds: internal load balancers and external load balancers. So let's think about it. An internal load balancer, let's say you've got 100 servers inside of your systems in your private network. That is an internal load balancer. An external load balancer is external to your systems, like your external publicly facing website. So sometimes people call them internet-facing load balancers for external load balancers and internal to your systems. We can use them both ways. Let's talk about some AWS specific concepts of their load balancers. When we're dealing with a load balancer, we have something called a listener. Here's where the load balancer listens for a request. Who's coming in with an HTTP or an HTTP request? I'm waiting. That's the listener. And it will literally be there for the requests. And a network load balancer is going to look at the protocols, TCP, UDP, TLS, TCP, UDP, and the ports. And it's going to listen for that. A target is where the load balancer is going to send its stuff. Meaning, it could be an IP address. It could be a range of IP addresses. Now, when you're using a load balancer, they're going to want you to use you're going to use private IP addresses on the inside of your load balancer, which further enhances the security of your systems. So if you've got an external load balancer facing the internet, your DNS will point to the external IP address of your load balancer, and all your servers behind that will have a private address. Which private addresses will they be? Well, they're all specified in either RFC 1918 or RFC 6598. And for any of you guys that want to truly understand any networking concept, guess what? There's this wonderful resource. It's free. It's called the Internet Engineering Task Force. Every specification for every routing protocol is there. You want to find a great CCIE? They made us read all the RFCs. It's the spec. It's the most authoritative place in the world. So the addresses that we're going to be using are coming out of RFC, which is the 10.0.0/8, the 172.16.0.0/12, and the 192.168.0.0/16. We can also use the shared address space, which comes out of RFC 6598, which is 100.64.0.0/12. Those are the addresses we can use on the insides of our load balancers. So a target is a system. What's a target group? You group a bunch of people together in a system, and that's your target group. Now, we can also set up something called sticky sessions. So with a network load balancer, if you're coming in here and you've got 10 different servers in the destination, when user one goes to server one, they stay on it until the entire time their connection is over. But an application doesn't work that way. An application load balancer normally will send your messages to the server with the lowest load. So you could start on server one, your next request could go to server two, and your next request could go to server three. Does it matter? Depends on how the application is architected. If it doesn't matter, wonderful. But if it does matter, no, we've got a problem. But don't worry, the load balancers can actually send a cookie to the user's browser, and the cookie will remember, send Mike to server one and keep Mike on server one until he's done for the day. So we can also deal with that, and that's how that works. Now, load balancers do a health check. What do they check? They check the target. Server, are you there? So they will check to see if it exists. So I'm going to draw this one out. I actually feel that understanding these health checks is so important, and sometimes the best way to deal with it is to just whiteboard it out. I love whiteboards. So let's say over here, we've got a load balancer. I'm a networking guy, so I'm biased to like network load balancers, but the reality is I use whatever the application needs. And then let's say we've got servers. Server, server, server. And let's say this is a web application. So over here, we're going to have a public IP address. We're going to use AWS terms and call it an E for an elastic IP address, but P would really be there for public. And then we have these servers. Now let's assume these servers are all plugged in via Ethernet. I'm going to draw a little Ethernet connection between these servers and the load balancer. Bear with me if the lines aren't perfectly straight. You reach a certain point in your architecture career where you can draw your pictures on a napkin, you take a photo of them, and you send it to a graphics professional to draw your pictures for you. Early in your architecture careers, you're drawing them yourself, but I've been an architect for a couple of decades now. So on a normal environment, what's going to happen is the load balancer is going, assuming everybody's healthy, is going to send some traffic to this server, some to this server, some to this server, some to this, and everything's great. But how does the server, how does the load balancer know those servers are there? Well, what's going to happen is periodically at every time frame, and you can tune the time frame, the load balancer is going to send a message to the server, are you there? And the server is going to say, woohoo, I'm here, I'm healthy, I'm happy, life's good. And then the load balancer is going to send a message to this server, are you there? And the server is going to say, I'm happy, life's good. And then they're going to send a message to the third server. Message is going to hit the server, and the server is going to say, yes, I'm here, life's good. And everything runs, everything's fine. And then out of nowhere, server 1 crashes. And these health checks occur constantly, ongoing. And what will happen is the server is going to send, the load balancer sends a message to the server. Nothing happens. Then the load balancer sends a message to this server and it says, woohoo, I'm here, I'm happy, I'm having fun. When's Cindy the cat coming? Now you got this next load balancer sending to this server and it's saying, I'm happy, I'm happy, I'm happy. Now, message goes to this server, it doesn't reply. Now, it already missed a message before. This is not a good thing. Hits this server, you're there, yeah, I'm here, life's good. Hits this server, yeah, I'm here. Sends another message to this server, no response. And after missing a certain number of responses, and these are typically tunable with most load balancers, could be 2, could be 5, could be 10, could be 3, could be 4, it removes it from the rotation. And how does it remove it from the rotation? It marks the system as unhealthy, and and because it's unhealthy, it's basically saying, don't send to this server anymore, it doesn't exist. And now the load balancer will only send it to this server and to this server. That's the way the health checks work with load balancers. Now, Chris, the next topic is security. So I'm going to use this as a natural pause to see if there's any questions before we go to the next one. How many servers can be watched by a load balancer? It depends on the functionality of the load balancer, their performance of the load balancer, and many, many other things. So, and every load balancer is different. So that's going to be an it depends answer. Good question, though. Yes, I showed a load balancer covering availability zones. The load balancer could also cover servers. The load balancer could be used to load share across firewalls. The load balancer could be used to load share across other load balancers too. So we can do a lot of things in architecture-wise. Good question. Chris, we go to the next one. To be specific, is the target group responsible? No, the load balancer is checking. The load balancer is always checking. The device that routes the traffic. The routers run their health checks. Load balancers run their health checks. DNS runs their health checks. It's asking the other people, are you there? Good question. Chris, we go to the next one. Do I think global accelerator is worth discussing? We're going to get into a lot of other things later, but not right now, Ken. We've got to focus and do it in a certain method. Is it necessary to use a combination of network load balancers, application load balancers, or just pick a type? Well, it depends. You can use a network load balancer. You can use an application load balancer. And sometimes you need both. Now, they won't cover this in the Certified Solutions Architect Professionals. I think they briefly touch it in the AWS Advanced Networking that has absolutely no networking in it, which is kind of hilarious. But when might you need both? Well, what does a network load balancer do well, Augustine? It's high speed. What does an application load balancer do very well? Intelligence. So let's say I was Google scale and I was using a microservices website. And it's funny because first it was all monoliths. Then we're all going to go microservices. Then let's not go microservices. Let's go microservices. And really what we're talking about is selecting the right technology for the business. And there is no best technology. So let's say we had a Google scale website that was microservices based. And that's also dependent on how many thousands of application developers you have too, whether it makes sense or not. But let's say we did. Now, for the scale of Google, We're not going to get away with application load balancers. They're going to be way, way, way too slow. So we'd have a network load balancer. Now we might have the network load balancer route to a bunch of little application load balancers. And by doing so, it's because the network load balancer is so much faster. So we could ultimately have a network load balancer that's going to route to multiple application load balancers. You can see why the better of an architect you become, the better you hire graphics professionals, or your company will give you graphics professionals to draw your pictures, because they want you focused on selling and closing deals. And then this could be microservice 1, microservice 2. It could be also small web servers too. Doesn't matter. And what will happen is then what we'll get is the network load balancers will load share across application load balancers, and then application load balancers will route to services or microservers or something like this. Some people call that a load balancer sandwich. This is a common architectural pattern, and I've been using this for 20 years. So it's like anything. All architecture is, since we don't touch anything as architects, is selecting the right tool and designing the system so they're going to meet the business requirements, whatever they are. Great question, Augustine. Do you deploy a separate load balance for each region and multi-region? You got to deploy based upon what your business needs are. One load balancer may not be able to handle multi-region. What are the business needs, Minesh? That's the question. We might need 1,000 load balancers in an availability zone. If we've got a big system, I'm not joking. We might need 5,000 load balancers, 10,000 load balancers, 50,000 load balancers in a really big enterprise. So what is your traffic pattern? What is the needs on the load balancers? Why are you using a load balancer? What are you trying to achieve? So these aren't simple answers. And the reason architects don't touch the technology, Minesh, is it could take me 2 weeks just to get the answer to your question. Maybe 3 weeks of asking the right questions to the client. It's the same reason when people go to the doctor and they say, I want this pill. And the doctor says, well, let's talk to you. Tell me what's going on with you. How do you feel? What are you doing now? What's working? What's not working? Before they can make a diagnosis and a plan. This is putting the cart before the horse. We have to know the what, the why. What are we doing long before we can answer these questions? I wish I could give you a simple question, but that's like a patient telling me from my old life, what pill do I take, Mike? And I don't know, what's your problem? What are you allergic to? So I hope that makes sense. Is it possible to use both load balancers to the same target group? Now you're going to set up a different target group on each load balancer. It's a great question. And Wesley, I'm going to bring in some Cindy photos at the end of the day, and I'm grateful that you always ask for her. I'm thrilled you're here. Antonio, when you say the load balancer stops sending requests to a server that is now, this means the load balancer will tell the auto scaling group to remove that server from that group? No, it's going to say don't send traffic to that server anymore. And it might even scale out an additional server from the auto scaling group. It just means don't go to that single server. You can also do load balancers without auto scaling groups or with auto scaling groups. So that's the same kind of thing. Good question, Antonio. I really like it. Although I would say if it wasn't for auto scaling groups, I don't think anybody would ever use cloud computing, given the cost of cloud computing compared to the data center. But that auto scaling group gives organizations the ability to build a website for average needs and then add capacity when needed, as opposed to standard, which is what enables certain applications like web applications to often be cheaper in cloud computing, while systems that run 24 hours a day, 7 days a week, especially high performance systems, are typically cheaper in the data center. But that auto scaling in cloud computing, that agility is extraordinary. So before we get back to the content, okay, it looks like we have another one. And I'm going to get to this question, even though, so the question is, can I tell you the different use cases between a VM and container? Well, it's more than a few use cases. What do you need to achieve? If you need high compute performance, do not use containers, use virtual machines. Virtual machines I can build you a virtual machine with 256 physical cores and 6 terabytes of DRAM. And I can put a GPU in that machine or 10 GPUs in that machine, and you can use it for artificial intelligence. I can give you a container to put something small and lightweight, something mini. So it all depends on the compute needs that you actually have and what you're trying to do. Good question, though. I think there's 2 or 3 others that I can answer. If the sandwich architecture is deployed, won't the network load balancer be sending all TCP to the out? Is there an impact on forwarding TCP? What makes you think it's TCP and not UDP? So it'll be forwarding network traffic. It'll be forwarding the traffic to the load balancer. And it may or may not be TCP. And isn't that an impact on formatting? No. The whole point of using the network load balancer is it could be 5, 10, 50 times faster than the application load balancer. So you use the network load balancer and now sending it to the application load balancers to do what they do best. You don't understand if you use Route 53 as a single point of failure, what should you do instead? Okay, so now let's think about this. Because I'm going to draw this and then we'll go back to the content after this. So let's say you've got 3 clouds. Cloud A, Cloud B, Cloud C. And the DNS, so let's say this is Route 53. Route 53 is over here. Now, what happens when Cloud A fails and all this goes away? Do you have any DNS to get you to Cloud B or Cloud C? You've got nothing. You're done. You could have these 2 other cloud computing environments up and running, but no traffic's going to be there. It's effectively like you're dead because you architected a single point of failure. So what do you do instead of this? Well, don't use Route 53. Go buy an industrial DNS solution, and you're going to put some DNS servers. You'll put your DNS servers in each cloud. Now, who makes really high performance interoperable DNS? Well, there's lots of them, but let's say F5 is a vendor that makes DNS for the last 20 years. You put some F5 servers in AWS. You put some F5 servers in Azure, or you put your F5 servers in Google. They all talk to the central DNS authority, which is over here, which is the main domain servers that serve the entire internet. And so let's say this is your global DNS. And all these things are here. And they're all talking over here to the DNS. Now, let's say that your cloud, let's say it's the AWS cloud goes down. It could be any cloud, the Azure cloud, the Google cloud, they all go down. All this goes away. Guess what? You still have DNS servers in Cloud B and Cloud C, and your traffic's still going to get them. So don't architect yourselves with a single point of failure, and you'll be in good shape. Hope that explains some things. And I'm going to end with Freedom Lands. We covered databases yesterday, so if you haven't seen it, please go back to it. Websites are far more than databases. Some websites don't even have databases, although most do if they're going to capture transactions. Now we're going to get into security, but it's an AWS certification, so we're going to cover it the AWS way. Understand you're going to be using in real-world applications industrial-grade security solutions from security providers, and you can find them all in the AWS Marketplace, the Azure Marketplace, and the Google Marketplace. So, and somebody asked if Cindy has a sister. Cindy does not have a sister yet, but my wife and I are talking about adopting a new baby every day, and that new baby would be a sister for Cindy. But here's the thing. If you want to see the Go Cloud Careers official Cindy sister, let me share her with you. She is absolutely beautiful. Her name is Sunny the cat. She resides at my chief operating officer's house, Christopher Johnson, and she is absolutely beautiful. One day we're going to introduce these two. So Chris, let me share Sunny, the beautiful Cindy friend. Those two send text messages to each other. You know, they borrow the computers. You know, they're all kinds of cute. Here you've got Sunny the cat. And that is the other main Go Cloud Couriers cat. Chris has got a beautiful Maine Coon. It's a giant cat. It's a very peaceful cat that Chris has that sits in the house and doesn't go out. My cat, I was trained to be a warrior from the time I was young. My cat out there actually is a bit of a hunter. You know, all cats are good. We're all different. So, you know, there used to be a movie that said all dogs go to heaven. Personally, I believe all cats go to heaven too. But, you know, that's neither here nor there. I just like anything with fur or feathers. So to let me know that you're awake, alert, and oriented, give me a hashtag AWS is fun, and then we'll talk about security. Come on, 162 out there and only 5 of you responding. I want to know you're awake, alert, oriented. While we're at it, throw us a like if you're having a good time. Subscribe to the channel. I see some of you have. Love it. I'm seeing some of you out there. Actually, while we're at it, before we get to the contest, join us on the How to Get Your First Cloud Architect Job webinar. We're going to hold one on Monday evening. We had an incredible one today. People participated from all around the world. It's free. We talked about how to get your first cloud architect job. We answered questions for a while. So also, we've got a completely free ebook that we wrote for you on how to get your first cloud architect job. If you haven't seen it, go get it. It's free. And heck, while you're at it, we wrote you a completely free guide on how to pass the AWS Professional and Associate exams. Guess what? We're there. And anybody that thinks you can just use a different region in AWS, I got to teach you networking. They're all connected to the same network, which means you can use AWS in 4 different regions. And if they have a global network failure, all the regions are down. It doesn't matter. And it's the same for all cloud providers. If the control plane that holds the cloud and orchestrates the cloud goes down, it doesn't matter how many regions you use. Plus, these cloud systems are highly distributed, and there are many more chaos failures that you can imagine that are there. So you can't just use 2 regions. You use a region, you have a single point of failure. When both regions goes down and you're the cloud architect, you don't want to be the person that's getting fired. So they're there. Just keep that in the back of your mind. The training we're doing here is somewhere between the associate and the professional exam level, for those of you that are asking in the chat box. It's kind of a hybrid in between the two. Good to see you, Chris Edmonds. Jim, that's a name I see a lot of places over the years. I love it. So wonderful. Now let's get back to the content. And I'm going to address the ChatGPT-based answer in there. Systems are designed to be high available until they're not. And I've been dealing with internet outages my entire life, consulting to internet service providers my entire life. And if you think any of them are highly available, there's a reason that no enterprise in the entire world will ever buy their wide area network from a single service provider. They always use 2. So keep it in the back of your mind. You're the architect. The decisions you make will either get you hired and promoted and paid more or get you fired. I'm here to guide you with how to create the best designs so you can build an elite career. So let's get into security. Now, there is a lot of security things that we need to understand. We need to think about who is responsible for what points of your virtual private cloud. We need to think about identity and access management and access to things. We need to think about industry compliance. We can talk about some multi-cloud strategy, multi-account strategies here. We can also talk about multi-VPC strategies. We can talk about access control lists, security groups, and we'll deal with a little bit of systems. We'll talk about some intrusion detection prevention. We'll talk about some distributed denial of service attacks. We'll talk about the AWS Service Catalog, the Systems Manager Parameter Store. So, you know, let's talk about who's responsible for what. So in a data center, you're responsible for everything. It's clear, it's cut and dry. You either do it right or it falls apart. In the cloud, you've got your stuff that you have to do right. And you have the cloud providers and you hope they do their stuff right. Think the cloud providers don't get hacked? Think again. Cloud providers get hacked too. So you got to trust that they're doing their part. And for the most part, the cloud providers are very good at what they do. Very good. So here's how I want you to think about it. You maintain the security of your VPC and your stuff, and AWS or Azure or Google maintains the security of their infrastructure, their underlying technology. Figure that out and you'll understand. So when it comes to security, the customer is going to be responsible for their identity and access management users and roles, patching of their systems, maintenance of their security in their own apps, configuration of their security options, physical security of the devices that connect to the cloud, and all of your security architecture. What your demilitarized zones look like, what your firewalls look like, what your remote access. You're responsible for all of that. It's not done for you. Graphically, this is what it looks like. They manage their servers, hypervisors, storage area networks, and networks, hopefully. They manage the hardware in their regions, whether they be local zones, edge locations, data centers, or availability zones, and you manage everything else. So you manage your data, your applications, your operating systems, your encryption, your networking, your traffic. So there's a lot that you've got to do. And then you have to hope that the cloud providers do their part. So first thing we're going to talk about when it comes to security is what the military calls need to know. Militaries are great at this. If you don't need to know something, you don't know. Now, in the business world, we can't say need to know. We've got to make some very complicated words and complicated sentences so we can feel proud of ourselves. And we come up with, in the business world, the principle of least privilege, which basically means if you don't need access to it, you shouldn't have it. So what do we mean by this? Don't give people access to information they don't need to do their job. And then you get less likely to get hacked. The second a person no longer works with you, yank their access. How common is this? Sadly, people often find out they've been laid off. You know how they found out? They go to check their email and they found out they were fired because all of a sudden their accounts are down. So that's really the principle of least privilege in action. I hate when that happens. It should never happen. But sadly, I've seen it happen to so many good people over the years. Well, so many people over the years. So principle of least privilege. Give access, only the level of access that's necessary for people to do the job. No more. And that's it. And revoke it. So I like to look at it this way. Here we've got two people. Let's say the person up top is my Chief Operating Officer, Chris Johnson. Let's say the person on the bottom with it says Administrator User is Chris's cat, Sunny the cat. Now, Chris needs obviously access to all my systems because he helps run the company with me. I lean on him every single day. I've got no system that Chris doesn't have access to. Now, let's say Chris's cat, Sunny, only needs access to the tuna database to see where the best tuna is that we have in our business. So Sunny the cat gets access to the tuna database and she gets her tuna. Now, when the cat wants to get to the HR database and affect my employee's compensation, she's denied. But Chris up top is allowed because he needs that for his job. That's the principle of least privilege in action. So let's talk a little bit about industry compliance. Let's face it, many industries are highly regulated and governments across the world come up with all kinds of requirements for them and businesses must comply. Now, the reality is all your cloud providers support all of these programs, but you may need to know that, if you need to support the PCI DSS for payment cards, AWS and everybody else supports it. ISO standards like 9001, 27001, 27017, 27018 common standards. AWS and pretty much all your cloud providers support it. FedRAMP, which is security standards for the US federal government. AWS and everybody else supports it. HIPAA, if you're dealing with healthcare in the United States, you need to be HIPAA compliant. AWS, Azure, Google, they're all HIPAA compliant, so they all know how to do these things. Identity and access management. We're going to get to that question about sysops. You probably should never take that exam, and we'll talk about why. But we'll talk about who should and shouldn't at the next break. From an identity access management, we're really talking about who are you, what are you allowed to do, and then keeping track of what you do. So the term identity and access management to me is ridiculous. So there used to be a term before we started making up word inflation and making things sound cool, and it was called AAA. And it meant authentication, authorization, and accounting. That's how I want you to think about identity and access management, or IAM. Authentication, who are you? I'm Cindy the cat, let me in the house. Okay, Cindy. Authorization, Cindy, you're allowed every room in the house because you're the queen of the house and you're the boss. Poof. Accounting, Cindy went and she opened up 2 cans of tuna, and then my wife has to go replace the 2 cans of tuna, so she needs to know to buy them. That is identity and access management in action without all the funny words that are there. Now, when we deal with AWS, they generally, and this is the associate level stuff, divide the concept into users and roles. Generally speaking, a user is a person, Cindy the cat, Christopher Johnson, Mike Gibbs, Sonny the cat. That is a user. And let's please don't anybody address the sysops role. I'll address it next. If a security person does sysops, it will damage their career. So please, we'll talk about that at the next break. I will address why security people should not study sysops, why architects should also not study sysops, and why maintenance people should study sysops. But we'll address what is sysops later. So identity and access management is going to tell you, who can do what by the person accessing the cloud. But we can create the concept of a user as Mike Gibbs. A role is typically the same thing as a service account for those of you that are familiar with Linux, where you have an account on one system that attaches to another account on another system. So identity and access management, let's look at what you can actually see here. So authentication is what happens when a user signs onto the system. Here, authorization is when you're given access to certain things, and accounting is tracking what the users actually do. So let's talk a little bit about IAM users. They're identities, people like you and me. They're created by what's called a principal, and a principal is someone that has administrative access to create users and their permissions. You can create an IAM user via the management console, the web-based, so you click things, the command line, or via software development kit, meaning do it over an API. Now, here's the things. An IAM user is permanent. So let's say I create an IAM user for Chris's cat, Sonny the cat, that beautiful orange Maine Coon that we looked at. If Sonny the cat no longer works with me, but I don't cut off Sonny the cat's access, she's going to be accessing her system with her cute little paws. Now, imagine an employee that's disgruntled and you don't delete it after they leave. What kind of damage they can do. So with an IAM user, you log in and you determine what you're actually allowed to access. Do you access virtual machines? Can you access object storage? Can you access a database? That's coming from the IAM user. So authentication options. When you want to authenticate to the system, or so for them to determine who you are, that's all authentication is. You can use a username and a password. We've all done that, right? And that's great unless somebody captures your password. So it's not the best, but it works. We can use something called an access key. And an access key is a combination of a 20-character key ID and a 40-character secret. The access key is used to connect to AWS via an API, and that's typically over the software development kit. We can also say the access key and the session token. When we're dealing with identity and access management authentication, we need to deal with something more complicated. So if we're going to get into access keys and sessions keys, when an IAM authentication needs to occur under an assume role, a token is going to be issued. And then we'll have the access key and a token. This is typically for federated identity and access management, like when you would use Active Directory to store your identity and access management. And let's be fair, right here, no organization is going to be crazy enough to use AWS identity and access management and have users add 100,000 employees into AWS. They will use Microsoft Active Directory, which is going to do the authentication for their entire domain, their entire company, and they will connect the wonderful AWS identity and access management to Microsoft Active Directory or whatever main system they use, and that's going to work. And they're going to do this with Azure Cloud, Google Cloud, the same thing. It's not. So keep that in the back of your mind. So if authentication is who are you, authentication is what are you allowed to do? And authorization is going to occur to see what specific privileges you have. And what we'll have is we're going to write a policy for your authentication authorization accounting, and it's going to determine who you are, whether you're allowed in, and what things you're allowed access to. You know what the default policy is of anything? Deny. So you're going to enable it. So typically what you're going to be dealing with is a security policy. These policies are written in JSON. I don't write any of these policies. I'm an architect. I design them. I don't get involved in writing these things. But here's what it's going to look at. You're basically going to have something called an effect. And that's basically what do you want to happen? Do I allow the person to use it or not? Then it's going to be the service. Do I allow them to access this service versus this service? And then we can get pretty granular and specific. And that's where you use the Amazon Resource Locator name, which you can see over here, and where it says resource in quotes, and then you've got the two dots, and then you've got and then inside the quotes you've got an ARN : AWS : IAM : and then you've got those numbers. That's a specific resource. So that's typically the way you would write a policy to determine who can access what. Now we also may have an action, and the action is what happens. And then, of course, we can add a condition or some optional variables. So, you know, when you actually look at a policy, it could ultimately look something like this. I wish I had a bigger screen or different colors, but really it's you allow which service, which resource, and what do you want. That's really all we're talking about. So think about it this way. You've got a user, they log in, and they can access S3, DynamoDB, but what else they can't access? The management console, because they don't need it for their job. Again, principle of least privilege. Why would I let a non-systems administrator be able to take systems on and off of my organization? I wouldn't. So we'll keep that in the back of our mind. So let's talk about some key IAM user concepts. Principle. And these are all could be potential test questions, especially on the professional exam. A principal is going to be an IAM entity that has the permission to access resources in the cloud. It can be the root user, an IAM user, or a role. Let's talk about the root user. The root user, when you first create the account, you have a root user. The root user has unrestricted credentials. We can do anything as the root user. You own everything. It's like being the king. So if you've ever worked with Linux, they say don't log in as root because you can break your systems. Well, don't log in as root unless you have no choice or have to do something special. Because root can do anything. If you're the root user for a big bank, you could take down the entire bank in seconds if you do something wrong. So protect your root user password. Use really strong passwords. Enable multi-factor authentication, which we'll show you, and don't use for programmatic access, or which means for one system to the other. Here's the way I like to see the root user. The king or the queen. You know, what was that song from Aerosmith? Kings, queens, guillotines? I don't remember. But anyway, so the root user is the king or the queen. They have unlimited privileges. And this is with any, pretty much, identity access management system. So now you know a bit about identity and access management. It's used to determine who can access the system. Now, we have IAM users. That's basically a person. But do you think it would be scalable to create on Microsoft Active Directory, AWS IAM, a policy for everybody? I make a policy for Chris. I make a policy for Alonzo. I make a policy for Tyrone. I make a policy for Eddie. I make a policy for Manuela. I make a different policy for Leo. I make a different policy for Chow. I could do that. I could do that for all 200,000 employees. I could. Or I could say executives, Chris and Alonzo. Senior managers, Leo. Very important non-management staff, Chow, Eddie. And I could create a policy for each one of them. And then that way, every time I hire regular users, pop them in the regular user folder. Every time I have a senior management, pop them in the senior management. Every time I have an executive, pop them in there. Create a rule set for systems administrators, the people that do the maintenance work. Create a different set of rules for the architects that need access to different business information. That's where we would create an identity and access group. So I create 20 groups of users, and I just, as soon as I hire a new person, I pop them in a group. I don't have to do their permissions. That's scalability. So the way a group is going to work is you're going to create a group, you provide permissions to the group, and then you add the users to the group, and poof, Bob's your uncle, everything's great. So typically, unless we change it, a user is a human, a role is a system. As far as the Certified Solution Architect Associate goes. Now, when we get into the professional and higher levels, and again, the professional is still introductory level, what we're really dealing with is we can actually federate our identity and access management, and that's what everybody else is going to do. And if I log into, if I tie my AWS identity and access management system into Microsoft's Active Directory, and Active Directory gives me authentication information, my IAM user became a role, which uses a token and a transitory token, which is going to make it much more secure. So we can use IAM roles. And IAM roles could be a person, or it could be a system. So an IAM role is used for one system to access another system, like your application server to access a database. IAM roles can be assumed by applications or services. And IAM roles are going to use short-term credentials that are going to be given out by the AWS Security Token Service. Why do we use tokens? We use it for a reason. They're temporary. Hacker gets access to my token. Guess what? 60 minutes later, which is the default time, they can't use it for anything. So by using tokens, it's going to be very short-term. Get access to my password. If I change my password every 90 days, you got 90 days to cause damage to me, right? But if we're dealing with an IAM role, which gives me a token, and the token times out in 60 minutes by default, and you capture it 30 minutes into it, you've only got 30 minutes to harm me. And that's why we use roles. And we can tune the token expiration from 60 minutes, which is the default, all the way down to 15 minutes, all the way up to 36 hours. Roles are going to be typically used to grant permissions to applications running on EC2 instances. And IAM roles are going to be used by people when connecting to an external identity provider, which is really the way most architectures are going to work. And it's just going to grant permission to an IAM user the same way as it would as a role. Now, I don't think this is in the associate exam, but I'm going to touch it anyway. The Security Token Service. The AWS Security Token Service is designed to provide trusted users and services access with a one-time temporary credential to access the system. The temporary security credentials will expire. You can specify the credential timeout from 15 minutes to 36 hours. And once it expires, it is gone. And that's, again, security. Now, I'm going to also talk about a cross-account role. Again, I didn't make up these names, a cross-account role. So let's say you've got your business. Let's say you manufacture autos, and you're an auto manufacturer. An auto manufacturer might need to buy brakes. They may need to buy tires. They may need to buy hoses. They may need to buy spark plugs or glow plugs or whatever stuff goes in a car. I don't know anything about fixing cars. I was told my car uses glow plugs, not spark plugs. I learned that for the first time. Who knows what that even means? It's diesel. But anyway. So if I'm Mercedes and I need to connect to Bosch, because Bosch parts are in Mercedes, I might need to actually connect Bosch to Mercedes for them to share information, right? Well, I can actually create a role for Mercedes to access Bosch, and they can be connected over the AWS network. That's called a cross-account role, where you access one account and you'll be giving access to another account. Now, I want you to think about this. You're now creating access to somebody else that doesn't even work for your company, but you might need to do this for business. So when you set up a cross-account role, you're sharing information with an external entity, which means you're opening yourself up for more money and more business, which is good, but you're opening yourself for more risk and more harm, which is bad. So you're going to have to manage the level of access that you give to people. In general, the partner company should only access what they need and no more. See why the military uses need to know? So always that need to know principle of least privilege is critical, but here it's most critical. So we can use cross-account roles to enable access to other AWS accounts. And it's going to be accounts that we don't own. They're going to be partners. So when we create a cross-account role, basically what's going to happen is an external identity is going to be uniquely associated with the role. The external ID can be a secret identifier that is going to be known by you and the third party. You're going to have to specify this ID when you define the trust policy for this. The third party will also have to provide the ID when they assume the role. And the permissions needed by the third party are going to need to be there. I'll give you an example of a cross-account role, and I'm going to move on to something. So we've got company A, company B, and company C, and they can all access each other through the AWS Identity and Access Management System. So how does a cross-account role? You create a role for the external user. The external user connects to the security token surface. And the external user provides a temporary token. Let's talk a little bit about a service role for an EC2 instance. This is basically if you want to connect, say, an SQSQ to your database, or if you want to connect one system to another system, that's called a service role. And basically, a role is taken on by your virtual machine or EC2 instance, and that way they can interact with other services. This way, your virtual machine may be able to take on an API call, post messages to an SQSQ, a system can access an S3 bucket, and can access a database. So that's going to be what's called a service role. Google calls them service accounts. Linux calls them service accounts, but same thing. You've got a system that wants to access another system. It's given a service role. And I'm sorry, this identity and access management stuff is dry. I'm not a systems administrator, so I don't work with it, but they're the only people that really do this stuff. Creating an identity and access management policy. Now, the policy that we create, assuming we don't get it from Active Directory, and even how we're still going to federate them and create policies, is going to determine who and what you can access. So if we're going to write the policies, we can write them a few ways. First, AWS will give you managed policies. Here's good for an administrator. Here's good for this. Guess what? They have some pretty good generic policies that are pretty much ready for most users. You just use them stock. But in life, you might need to customize them. So you can create a customer managed policy too. You could make it yourself. So kind of keep those in the back of your mind. A managed policy is a standalone policy created by AWS, created by people that know what they're doing with these kind of things. They're optimized for normal and common use cases. Typically speaking, they've got two major predefined roles. The first one is administrator access. Basically, you can access everything. And then they have a power user, which means you can access everything other than identity and access management. So how you want to create an identity access management policy? Well, you can do it a few ways. You sign in to the IAM console in AWS. In the navigation page, you can choose AWS managed policy. Poof, you can do that. It's pre-made, it's ready to go. You could also make your own. You can create your own customer managed policy in your own account. Nobody else will see this. And if you want to do it, you can. Now, when you want your own managed policy, how you want to do it? Well, if you're a JSON programmer and a systems administrator and you're used to this stuff, write your own custom one from scratch. Make it perfect from you. It's great. Or there's an AWS policy generator. It's a web page you go to. It asks you a couple of questions like a wizard, and then it spits out the policy for you. Or what you could do is you could take one that already exists and you can share it. Here's what the AWS Policy Manager looks like. Policy generator. You go to this website, you select the kind of policy, and they just tell you what to do. It's really simple. It's really basic. It's no big deal. Or you could create your own managed policy. And like I said, if you're a JSON programmer, you could write this. Here we've got a JSON policy. It says allow the ability to attach and detach of an EBS VM or basically a block storage VM. It tells you where the resource is located and it gives you some specific conditions. You can write that too if you want, or you can just take a policy and tweak it and edit it. But the choice is yours, how you want to manage your systems. So you create the policy and then you have to apply it. You apply the policy to a user, you apply the policy to the group. So with a user policy, we can create per user. Like I said, that's going to be a scalability nightmare. We can create a managed policy that applies to all systems administrators, and we can create a group policy where we create a policy for a group and then add users. This is the way most people do it in identity and access management on everybody's platform. You take an account, you create groups, administrators, developers, test users, and then you add the users to the groups. Like John and Grace, for example, are admins. Dave, Jake, and Emma are developers. Mark, Joe, and Ben are testers. And by doing so, you pop the people in the place that they belong. So keep that in the back of your mind. So let's talk about further securing your account with multi-factor authentication. Well, if I can guess your username and password, or I can use a password machine or a GPU to hack your password pretty quickly, your password's not so good. But we can use multi-factor authentication, which is basically using more than one thing. Iris scan, fingerprint, card, secure ID, digital token. That's really all we're talking about. We all use it in our everyday lives. You want to log into your bank, it sends you a text message, then you enter the special one-time key. That's an example. There's authenticator things. So we can further secure our accounts with identity and access management. You log into your account, maybe your username and password, you're sent a challenge, and then you provide your one-time password, and poof, you're allowed in. Well, we've got a lot of identity federation stuff to talk about, so I'm going to take a 2-minute break here, a 5-minute break, and answer some questions that are here, especially some that were dangerous that were in there. For a cybersecurity professional, would the solution architect be better to pursue, or would that be more of a sysops? Matthew, let me tell you what sysops is. It's the maintenance person. So Matthew, do you want to be a security architect? Do not touch sysops ever. It will destroy your career, and I'll tell you why. Do you want to be a security engineer? I probably still would never touch sysops. So here's what sysops is: maintenance. Matthew, one of the reasons that I recommend people skip the AWS sysops is as follows. Unless somebody wants to be a systems administrator because they love it, it is the lowest paid tech career in the world. It pays like $60,000 on average, where the average cloud architect, solution architect earns $237,000. So there's that. The second thing is brand. When it comes to building an elite career, you have to build a brand. So if you have a physician that went to Harvard Medical School and did a fellowship at the University of Pennsylvania Medical Center, they look great on paper, right? They do. If you're a cloud architect and you've got a TOGAF and you've got a certified solution architect professional and an MBA, you've got an elite brand. You don't need a degree, but that's an elite brand. If you are an airplane pilot, would you put on your if you're a physician, would you put on your resume physician / dog walker / babysitter? Or would you say I'm a physician? And ultimately, what happens is when you spend your time preparing for somebody else's job, like sysops, it has nothing to do with cybersecurity, so it's not going to help you at all in your career. And not only have you spent your time, which could be focused on building your career, learning more cybersecurity, but you're learning somebody else's job, which doesn't help you, but now you went and damaged your brand. You've taken a cybersecurity brand, which could be a $150,000 job, and mixed it with a $65,000 job, and now you're worth $80,000 to $90,000 to the outside world. So I want you to focus your career on your career, leave everybody else's career alone. I know many hiring managers, and I'm one of them, that will try not to interview people that have more than 3 certifications. And it's not that we don't like certified people, it's that we want to hire people that have a focused skill set, not people that have focused their thing. So I want you to look at champions. Simone Biles, the Olympic gymnast, she's my favorite champion. You know what she does? Gymnastics, strength and conditioning for gymnastics. She gets recovery work, probably massages for gymnastics, and she's the world's greatest gymnast. You know what she doesn't do? Marathon running. So keep that in the back of your mind. That's why I would tell you never to do sysops unless you want to do sysops. It is not going to help you in any career. Plus, it's the lowest paid certification and lowest paid career. So if you want to build a big career, don't mix your big career skills with your little career skills. So I also want you to get this complete guide, why tech skills are not enough. Because Matthew, there are places where you can invest your time, and I want you to. Did you know, according to salary.com, the average someone with strong business acumen skills earns $558,000 a year, which is what we've seen in our experience when we coach business acumen and other people. So do you want to focus on your skills that earn you $500,000 a year, or do you want to focus on skills that pay the lowest in the entire tech career, especially if you're already above that? That's why I say, don't waste your time. Is IAM used in restricting web applications, or simply in the case of migrating user accounts? IAM is used in everything. Everything you do in a system, somebody should determine who you are, what you're allowed to do, and then track what you did afterwards. Everywhere, not just web applications, everything. For an IAM user, would there ever be a case where multiple users should share a device account? No. You don't share users, you create them. Because what is the goal, Matthew? I have to know who you are, what you can do, and I have to be able to track it. So let's say 4 of you share the single account. How do I know who did what? So we always want to separate it out. But great question, Matthew. Some of these questions are great you're bringing in.
Yeah, I'd like to chime in here also from a non-tech answer here. Let's look at the hotel as an example. We make keys for your rooms. It's a single device that makes keys. But we've got 50 users. We're not going to all use the same login because somebody's room gets broken into, or somebody's key gets stolen, or something. We're going to want to be able to audit all the way back to the creation of that key. So even from a non-tech industry standpoint, it's single user for everything.
Yep. So there's a couple others. What does the 60-minute timeout mean in relation to IDM? Does that mean every account request, every minute, or every hour? No. So we were talking about a token which times out. So if I'm accessing a system via token and my token gets taken by a hacker, they can only use that token for a period of 60 minutes max. Every 60 minutes, a new token will be issued to make sure that the people can stay in, but they're using different passwords. It's just, it's like rotating passwords, but it's done automatically by the computer instead of you trying to change your password every 60 minutes and trying to remember all those passwords. That's all it is. Great question, FB. Do you need to learn DevOps tools to be an AWS consultant or solutions architect? Well, we got to stretch now. A solution architect has nothing to do with DevOps. The solution architect is understanding business, meaning understanding business problems and figuring out which technology solutions you use. A solution architect, a cloud architect, an enterprise architect, you will not be touching the technology in your job, ever. You won't even be allowed to. If you work for AWS, Azure, Google, Cisco, IBM, HP, Accenture, Deloitte, KPMG, Capgemini, the architect will design the solution, present the solution, and sell the solution. Once that solution's done, DevOps engineers are going to come in there. I'm an architect. I don't do DevOps. I'm an architect. I don't code. I'm an architect. I don't configure. No, I have to be able to understand people's balance sheets, their financial statements. I've got to go sell billion-dollar deals, and I do it all the time. I've got to negotiate billion-dollar deals. I've got to negotiate deals. I've got to negotiate resources. I've got to manage resources. I've got to manage stakeholders. I've got to lead architecture teams. I've got to deliver presentations. I've got to entertain clients. But no, we don't do that. Now, a consultant, I don't know what a consultant is. A consultant can mean anything. If it's an architecture consultant, no. But if you wanted to be a DevOps consultant, you better know DevOps. So it's all about having the right skills for the right job. For the architect role, please download the completely free guide on how to become an architect, and please attend the Monday evening completely free webinar on how to become the ultimate cloud architect, and we'll cover 100% of those things. 100%. Because I want you to actually get it. We'll go over the role. And that's where the confusion is. And you know, Tay, you want to hear the saddest thing? I've had a lot of students, because there's some certification provider that was telling people that you should get a developer associate, a SysOps associate, and a DevOps associate certification. And I don't know why they would recommend 3 different careers for someone so they can spread themselves so thin that they wouldn't know anything on an interview. I'll give you an example. I had a student, Arun. He was a great guy. He came to me. He kept going on interviews and nobody would hire him. He was like, I keep getting all these techie, DevOps-y interviews. I'm like, what's going on? I said, Arun, can I see your resume? In our Cloud Architect Career Development Program class, I took his resume in the class. I said, Arun, I'm going to get rid of every word of DevOps, all this maintenance-y SysOps stuff. I'm going to get rid of all of it and anything related to coding. I said, we're going to talk about presentations and sales and RFIs, RFPs, RFQs. We're going to talk about designs, managing stakeholders. He went on interviews with 3 companies. He had 3 offers inside of a month. He took one at TELUS, and then he went to a bigger and better one. He's having a great time. An architect is a very special position. Half business, half technology professional. It has nothing to do with DevOps, SysOps, coding, or any of those things. That is, your question is, why do you not consider an industrial DNS anything else than a single point of failure? You're asking because you don't know how they operate. Okay, Dennis, I want you to think about it. If you have 3 completely independent organizations, completely, that have no relationship to each other, and one of them goes down, you still have them all that goes up. If you have 3 things, let's say you have 3 brothers and sisters, and the parent gets sick, all 3 brothers and sisters get upset. But if you've got 3 unrelated systems that aren't connected to each other, and they're running simultaneously other than exchanging information, and you've got 3 separate sets of DNS, one of them goes down, who cares? You still have the other 2. So the DNS, the global thing, is the entire internet. These are major servers for the entire internet, not AWS's thing. So when the single point of failure is, is by being there, being in a single cloud. Now, if some of your stuff's in Azure, some of your stuff's in AWS, and some of your stuff's in Google, and Google goes down, AWS and Azure are still up. They're not related to each other. This is different than if your stuff is Amazon, and you got an Amazon region in Europe and an Amazon region in America, and they're on the same network, connected to each other, routing and switching, sharing routes between each other, common control plane. One goes down, the other one can be infected too. It's a very different situation. I hope that makes sense to you. Wesley, you would guess my password would be Sydney the Queen 23. You know, Wesley, if I didn't grow up in a highly secure environment, if I wasn't raised by Marines, if I didn't train martial arts for 30 years and work in cybersecurity, every password I have would be some version of Cindy. But given the tactical background I have, given the executive protection background I have, given the cybersecurity background I have, I use like these 48-word letter passwords for absolutely everything. Are there unique IDs for tracking who accessed the resources in an IAM group? Every user has their own ID that's being tracked. Exactly. And even if they're in the group, so I've got Christopher Johnson and Alonzo Coleman, 2 incredible executives that are like brothers to me on my team. Chris logs in as Chris. Alonzo logs in as Alonzo. Yes, they're in the same group, which means they have the same level of permissions, but I can see what Alonzo did, and I can see what Chris did. They're all separated out. That was an extremely good question, Matthew. You're asking some great questions. Okay, so we're going to go back. But I need to know you're not sleeping. So give me a hashtag SAA-C03. SAA-C03. Okay, and a like if you haven't liked, subscription if you haven't subscribed. And now I'm going to talk about identity federations. Now, this is a concept from the Certified Solutions Architect Professional, but I don't feel right teaching you about AWS IAM and acting like that's the way it's going to work, because it isn't. Everybody who manages anything is going to be using federated identity and access management. And as my physics professor said, education is an ever-decreasing number of lies. So in other words, when you take the lowest level, you get a lot of things that are partially true. When you get to the next levels, you get to learn a little more and realize why things aren't true. When you reach expert level, you go, wow, a lot of this stuff isn't true, but then you'll know. And that's why I want to give you to all as much as I can. So organizations will use what's called an identity federation, because how many people do I really want to hire to go click into the AWS management console and start adding users? None, honestly. Especially if I'm in a company that's been in existence for the last 20 years and all of my users are in Active Directory, Microsoft Active Directory, which is what the companies are going to use anyway. So why would I pay somebody to do 10 times double the work? I wouldn't. So we're going to deal with something called identity federations. And basically what's happening here is you've got an identity, who's a user, an identity store, which is a system that stores the identities, like Microsoft Active Directory, and an identity broker, which is something that acts between the user store. Ever log in? Ever log into a system and they say, would you like to log in with your Apple login account, your LinkedIn account, your Gmail address? That's federated identity and access management in action. So now you know the basic elements of identity and access management. And you know, the way this is going to work is the user is going to log in to the system. And what's going to happen is the identity provider is going to authenticate the user, determine who they are via an identity-based store, which is typically done via the LDAP protocol. And the identity provider will then generate a security assertion markup language assertion token request. And it will get the information and submit that to the identity provider or the identity broker, which is that middleware between you and the identity provider. Then the identity broker is going to set up something with an assume role with SAML, and it's going to hit the security token service API, and it'll pass what's called the security or assertion markup language assertion to the role, which will assume the role. And then what'll happen is the API will respond, and if it responds successfully, it's going to provide a temporary security credentials, temporary, so you can be used just temporary this time. And with the temporary credentials, the client application will be able to perform an operation in AWS. So that's kind of the way, you know, this thing is going to work and those messages going back. Identity federations will enhance scalability because you can use a big industrial application that's designed for it, like Active Directory. And realistically speaking, you're creating what's called the trust relationship. You're saying AWS's IAM in my account will trust my Microsoft Active Directory, and therefore I believe it. That's really all it is. And we can use lots of providers: Google, Amazon, Facebook, Apple, Twitter, LinkedIn, Active Directory. And by doing so, really what we're talking about is we're just trying to make it scalable and simple. I'm also going to address single sign-on, which is more of a certified solution architect professional topic, but I want to address it briefly. So you could log into every single system. I worked for Cisco. They were a high security environment. I'd log into the main thing. I'd log into another system, another identity password, another password, another password, another password. At some point, I had about 50 different passwords when I worked at Cisco. And you know what I did? In those days, I put these little sticky notes on my monitor, and each sticky note was the password I had for every account. Now, I had really secure passwords. They enforced a secure password policy. And then you'd run around the hallways and you'd see people with little sticky notes on their computer. You see this in every building, by the way. That's because somebody enforced a password policy that was so crazy that people couldn't remember their passwords. Then in the end, they put all their passwords directly on their desk, which was a nightmare. So single sign-on is designed to make things easier. You log into one system, and it just gives you access to everything with your same login. So architecture is a trade. It makes it simpler, but less systems, one password gets compromised. So kind of keep that in the back of your mind. Single sign-in is often used in a federated environment. You sign in to Microsoft Active Directory, Azure Active Directory, Salesforce, or any other kind of identity and access management platform. And then poof, you're allowed to be wherever you need. So it enables you to authenticate once to the identity provider, and you don't need to sign in again. So a lot easier to use single sign-on from your Active Directory on-premise, and then have access to everything in the login to S3, DynamoDB, and your virtual machines. That's all we're really talking about. Now we can also talk about Amazon Cognito. Amazon Cognito is a service that provides authentication, authorization, and user management for web and mobile apps. It provides a means to connect to identity providers. Cognito will enable organizations to synchronize identity management and data across mobile devices. Cognito will enable you to sign in directly with a username and password or with a third-party provider like Facebook or Google. Pretty simple. User authenticates to Cognito. They trade tokens for credentials, and then they can access the systems. Cognito is going to use the concept of a user pool and an identity pool. As far as the user pool is going to be a secure directory inside of Cognito that will enable you to manage your users in a single place. And once you authenticate, Cognito will give you a temporary token. It'll be a JSON web token. Cognito identity pools will provide temporary AWS credentials. The key is temporary, is that if you get access to them, they're expired pretty quickly. So they work great. And Cognito can work with authenticated people or unauthenticated guests. I'm going to briefly discuss the AWS directory service. So I mentioned organizations will have their own Active Directory servers. Everybody does. And they manage them and maintain them. But if you didn't want to manage and maintain your own Active Directory servers, you can get a pre-managed Active Directory server from AWS, which is where they provide hosted, dedicated tenant Windows Active Directory servers. And these are going to be relatively high availability servers, meaning they're going to be in 2 availability zones, which means they're going to be pretty good by default. And this means your Microsoft dependent workloads hosted in AWS will be able to use the Microsoft Directory services. Of course, if you have your own in AWS, Azure, and Google, and AWS goes down, you don't have to worry about it. If you use theirs that are only hosted there, and that goes down, you lose access to everything. So, everything is a trade. So you can look at it this way. You've got your Active Directory service. You can create your managed directories, deploy or migrate your apps, enable Active Directory aware applications and manage aspects. It's the same thing you've been doing with Microsoft Active Directory for the last 20 years. And what is it? Amazon is hosting your systems. So in order to keep your system secure, you want to keep people out at the edge. Like your front door, right? You keep it locked. And people are allowed in that have a key, and people that don't have a key are stuck outside trying to knock on the door, trying to get in. Believe me, my cat hasn't figured out how to use a key. So she knocks on the door, and if I'm not here, she's stuck outside. Well, that's kind of life. So the key is to keep bad actors away from you. Now, identity and access management, as far as security is, I'm already here. Let me in. I look at Cindy. I see her pointy little ears and her whiskers. She's doing this on the door. I know she wants to come in. I open the door. That's me. But, Cindy's out there. What if there was a bobcat in the community and I didn't want the bobcat to come in? Or I've been watching the show, The Vampire Diaries. What if I didn't want the vampires to come in? Well, what if I could put a 1,000-meter tall wall around my house that doesn't let people in? That's a firewall. So I'd rather the 1,000-meter tall wall than having somebody at the front door knocking on the door that says, I'm here. Keep the vampires out. Vampire Diaries, great show, by the way. I've been watching it. Yeah, it's just personal perspective. So We want to protect the perimeter of our network with a firewall. And a firewall basically will look at all traffic, that it'll block all traffic from coming in except what you particularly allow in, and it'll allow you to go out to the internet and come back without others to come in. Now, that is traditionally what a firewall works. Now, I'm going to tell you about AWS WAF, which is something that I will never use in anything that matters. And the reason I won't use it is it's a great firewall, but it's got two problems. It's proprietary. And when I use two clouds, I need to use the same kind of firewalls in both clouds, not different ones. And here's the problem with AWS WAF. Let's say this is my firewall. You breach the firewall with WAF, you're going to get a CloudWatch alert that says you've been hacked. If I use a next generation firewall, it can be adaptive in nature. So here, instead, if this is WAF, you get notifications via CloudFront. You've been hacked, you've been hacked, you've been hacked, you've been hacked, you've been hacked. Okay, great, I've been hacked. If I've got a Palo Alto firewall or a Cisco firewall or a Fortinet firewall, a Checkpoint firewall, all of a sudden a packet gets through that's not supposed to happen. The firewall goes, whoa, not supposed to occur, set up a new rule and block the attack and stop the attack in real time. So traditional firewalls like WAF are good, but they don't adapt to threats when they occur. You get notified that there's a problem, then you got to go figure it out. Modern and next generation firewalls can adapt. They can fix the problem. They're like your credit card. They're like when you take your credit card and you launch your day in Florida, and then you go to California, and then you fly to London, and then you're in Dubai the next day. You know how your credit card company sends you an alert? Did you mean to spend this money? Or they shut your card off? That's what a next generation firewall does. But we're here. It's an AWS certification, so we'll talk about AWS WAF. And it is a web application firewall that is used for controlling access, and it protects against common attacks, that's the key, that can negatively impact your performance, such as DDoS attacks, SQL injection attacks, cross-scripting attacks. And whoever uses your WAF can create custom rules to allow or block web requests, like any other firewall. And that's what WAF is for. You can pop it on certain places. If we were to use a web application firewall, your users can create rules that can determine who can come in. And this enables us, we can create all kinds of rules to block people from certain countries, for certain requests in the headers, strings that appear in the request, like a regular expression. We could look at the presence of SQL code, if we think it's likely to be malicious to a SQL injection, the presence of a script that could be used in a cross-scripting. It's a fine, standard, old school firewall. It's a good firewall, but it doesn't adapt. So your mileage may vary. Do you want to have a guard dog that blocks until it gets, or do you want a guard dog with another guard dog behind it that says, okay, you passed my first guard dog, but I'm gotcha. That's me. I want more security. So WAF is a web application firewall. It's going to monitor for requests, HTTPS requests, because it's a web firewall. You can put WAF on a CloudFront distribution, which is one of the content delivery networks Amazon uses. You can put it on an API gateway, a REST API, or application load balancer. It'll block connections at edge locations before they get onto your system. And WAF controls access to content that you can specify. I might consider using WAF along with other more serious firewalls. WAF will give you granular controls like any other firewall. You can create a web access control list, rules, and rule groups, for example. And rules are going to be statements. Allow Cindy the cat in. Block Joey the cat out. So realistically speaking, and then you'll be able to get traffic metrics and etc. via CloudWatch. How's it going to work? You're going to enable WAF on the application device. You'll create a policy that filters access to the device. WAF will look at the traffic and say it either conforms to the policy and it's allowed, or it doesn't conform, then it's dropped. And if a new attack occurs, you can create new rules. So keep that in the back of your mind. You put WAF, you put it on your CloudFront, your load balancers, your API gateways, you set your policies, and poof, you're done. And, you're going to combine these things. If you were going to use WAF, you could put it on, say, your load balancer. Then you're still using an access control list, and you're still using the security group. This is not a security architecture I would ever design, but I might for a small website, not an enterprise. So let's talk about a distributed denial of service attack. Very common web attack. So architecturally, I'm going to show you what it looks like, and then we'll talk about it a little bit. So a denial of service attack is I take my server and I attack you. A distributed denial of service attack is I take my server, I infect a bunch of servers, and then I use all those servers to launch an attack on you. And I try and overwhelm what you can handle. Now, dealing with a distributed denial of service attack is a big deal, and it takes a lot of things. So I want you to think about this. Here's what a distributed denial of service attack is. I've got a web server that can handle 5,000 requests per second. Normally, I get 2,000 web requests per second, and life is good, right? Now, I take 10 servers and I launch 50,000 web requests per second at you, and your server can only handle 5,000. Your server CPU hits 100%. Either the server crashes or it's in such a bad state that I can attack your server pretty easily. That's a distributed denial of service attack. So it is going to take a lot to prevent these. So preventing a distributed denial of service attack is kind of like an onion. You want multiple layers. You peel off the top layer, you got another layer, you got another layer, you got another layer. Note, anytime we talk about security, we talk about onions. Also, if you've ever seen those really cool Russian dolls, you got a little doll which sits into another doll, which sits into a bigger doll, which sits into another bigger doll, and another bigger doll. One of my grandmothers had it. It was really cool. But it's the same kind of thing. You want layers inside of layers. So we want to block all unwanted traffic with access control lists and firewalls. We want to put host-based firewalls on our system, security groups. Well, let's talk about auto-scaling and how it can help you survive an attack. Nobody will talk about it, but it's serious. I want you to understand it. If we can handle 5,000 web requests per second, right? And somebody's spewing 50,000 web requests out of a second, right now we're in trouble. We could survive the DDoS attack by scaling out the servers. They can handle 60,000 web requests per second. Now we're going to pay a fortune to add those 10 servers to survive the DDoS attack, but we can still be up and operational in business. Cloud computing is the only way you can do that. Now, in a private cloud, you can do it. In a public cloud, you can do it, but cloud computing enables that auto scaling, which is beautiful for these things. So we're going to use a firewall to block stuff at the perimeter. WAF can recognize common DDoS attacks. All firewalls can recognize common DDoS attacks. And then we're going to also use a content delivery network. And a content delivery network we'll talk about later, but here's the thing I want you to know for now. They're only going to send a legitimate request to the server. Now, in most of these DDoS attacks, they send bad requests to the server. So I send you 100,000 bad requests per second. By using a content delivery network, guess what happens? None of the bad requests, those 100,000 per second, actually go there. Keep that in the back of your mind. So they're there. So typically the content delivery networks will give us a DDoS protection service that'll stop that. It will also use some signatures, for example, that'll look at common attacks and not send them. So that's kind of what you're dealing with these DDoS platforms. Now, Amazon's got their DDoS platforms that are called Shield, and there's a typical Shield Standard and Shield Advanced. Let's talk about the difference. Shield Standard is given to anybody that uses WAF. All right, fine. Shield Advanced, you actually have to pay for. Now, Advanced Shield can provide some protection to your load balancers, your virtual machines, your CloudFront distribution, your DNS, any global accelerators. And if you're using AWS and Security Matters and using CloudFront in addition to your other content delivery networks, which I hope you're using, more than one, and even Amazon doesn't only use CloudFront, they use more than one, and we'll do an experiment where we get to test them all when the time comes. So Shield Standard is basic. It's going to protect against 96% of the attacks. And there you go. Basic SYNAC attacks, reflection attacks, HTTP slow reads. It blocks based on policy. So You got an attack, it doesn't conform with the policy, you're using Shield standard, you're done, you're hacked, it's over. So, if it doesn't matter, think about that. And Shield Advanced is a better version of DDoS protection. You pay extra for it. They do give you a DDoS response team that's 24/7 if you've got business or enterprise support. And now it's a little smarter. It can actually look at traffic patterns and can automatically deploy ACLs and things. So Shield Advanced is actually relatively reasonable DDoS protection. Again, you're still going to need your demilitarized zones and your layers of firewalls, but this is something to protect you before you hit the firewall. So, there's that. Now, if you want it, you could use a service called Amazon Guard Duty to monitor your AWS resources, and it's going to monitor your CloudTrail, your DNS, your VPC flow logs. It's going to look for patterns of behavior with compromised systems, but that's going to work for AWS. Mind you, there are industrial systems that can manage all of your events in all of your clouds, which are going to be better for things. Now, Amazon also has the concept that's this protocol called Inspector. An Inspector is going to be an automated security assessment service that's going to help you. It's going to look for exposures and deviations from best practices, and it's going to give you a detailed list. Well, here you go. You got a machine that's going to give you a detailed list of what it thinks is your vulnerabilities. If you believe in automatic, oh, great. I don't. I believe in assessing things. I believe in hiring penetration testers to try and break in. I believe in finding people to assess your physical security. But if you think it could be done by an automated tool, go have at it. And I think you should still use automated tools. Just don't expect the automated tools to do things. There's another service from Amazon called Macy, and it's a fully managed data security and privacy service that uses machine learning and pattern matching to discover and protect your sensitive data. Macy automatically provides an inventory of S3 buckets, including a list of unencrypted buckets, and then it provides pattern matching. Look, let's be fair. 16% of all cloud computing attacks occur to misconfigured S3 buckets, and here's why. Anybody can configure an S3 bucket. That's nothing. It's knowing what to configure and why they're configuring it that's the problem. And 99% of the people that have taken an AWS certification know the name of a service and how to configure it. They don't know what the services are, what the services are for, how they're used, the strengths and weaknesses of them, so they just configure stuff. So the good news is Amazon realized that their clients were getting hacked every day of the week, and I'm not joking, from misconfigured S3 buckets, so they decided to come up with a service that could help alert you when you've made mistakes. The solution is educating your users so they know what to do and why to do it, and then this is a good backup to catch stuff that they may have made mistakes. There's also other industrial tools. The next thing we're going to talk about is the service catalog, which is pretty cool. Controlling what you put on your network is essential to an organization's security posture. Now, I can tell you in my youth, I ran around with something called a sniffer or a protocol analyzer, and I would plug it into the networks for my 6 months as a network engineer before I became an architect, and I would start looking for the traffic on the network. And I'd find this computer was accessing porn all day long, this one was accessing music videos, this guy had a secret hidden web server that bypassed the firewall, this lady, she had a streaming service and it was all behind the firewall. All these things were an opportunity to hack the system. So companies would lock down what you can do, and that's what the service catalog is for. And this is fantastic. With the service catalog, you can control what people actually put on the systems. So you can specify an AMI or a virtual machine image, which actually works, which servers people are allowed to use, what software people can use, what databases we can use, even the way an application architecture can be deployed. So you can create a list of approved services. This is unbelievable. And you've got a user that accesses the service catalog, they can launch a CloudFormation script, and they can only deploy certain things. So all in all, that's a really great security service. If you keep the bad stuff off of your systems, you're there. Now, another security option offered by AWS is the Systems Manager parameters there. And this is another component of the strong security posture. Why? Where are you going to store your passwords? You're going to put them on sticky notes on your desktop. I've seen it. You're going to take photos of them, right, and store them on your iPhone until your iPhone's stolen. Believe me, I've seen this. You're going to use your kids' birthdays. Come on, you name it, I've seen it. So there are places where you want to store your software licenses, your passwords, your things like that. And AWS provides you a systems manager parameter store. It's quite a good, secure environment. You can keep your information in there. API keys, license codes. So they provide a secure and encrypted environment for you to store sensitive information. You can store your information in there. You can encrypt it in there. You can separate your codes from your passwords. It's a great way to audit things, and it's a great way to track password use. Next, there's something called Security Hub. AWS Security Hub is a service that provides users with a broad scope or an extensive use of a user security password. It's going to simplify how users understand and improve their cloud security posture, best practices, collecting data. Look, there's lots of industrial packages of this that are made by security providers too, that do nothing other than security. But Security Hub will provide you a central view of security and compliance posturing. AWS Security Hub is primarily an aggregated analytical tool that's going to work across your AWS accounts and services. Let's talk about the Firewall Manager. Again, an AWS proprietary thing to manage their AWS proprietary stuff. They have a firewall manager that you can centrally set up and then push your configurations to all your WAF firewalls, AWS Shield, security groups, that kind of stuff. And it's great if you're using AWS stuff, but the AWS security services don't equal the level of what you could buy from Palo Alto or Fortinet or Checkpoint or Cisco. So determine what you need. But it provides a simple environment for you to manage your AWS things. So we're ultimately going to get into the AWS applications and services section, and that is a long, long section. So let's pop it open for a few minutes of questions, and then we'll get into that content. Make sure you watch the originals. It's off the Vampire Diaries spinoff. Hold on, I'm going to put it in my notes section of my computer right now, Chris, before you go to the next one. So the originals. I will be watching it, and I'm very grateful for that suggestion. Thank you, Toya. Can I add some light on what a power user is? Absolutely. Great question, Samuel. So a regular user is very limited in what they can do. An administrator can do basically everything. A power user is someone that can do everything but create identity and access management users. So administrator, everything. Power user, everything but accessing, creating users and accounts. And a regular user, whatever access you give them. That's an excellent question, Samuel, and I'm so glad you asked it. And Matthew asked a question, which it's a great one. So would WAF rules be the same as IPS signatures? No. WAF doesn't have any intrusion detection, intrusion prevention. No, next generation firewalls do. So that's the whole problem with WAF. It doesn't have any of it. But let's talk about signature-based WAF versus signature WAF versus analytical-based WAF. Here's a signature. And some identity intrusion detection, intrusion prevention systems use it. The signature is, I've seen this attack before, and I'm ready to handle all the attacks that I know about, like your antivirus. Anything that you've been told about, you can block. And that's great. An adaptive intrusion detection, intrusion prevention system, the kind that you get from Palo Alto or Fortinet or Checkpoint and Cisco, not only uses signatures, but it looks for patterns of behavior that are anomalies. Too many hits coming from a certain IP address block, patterns of traffic that don't look right, anything that just feels off. So for those of you that are parents, if you've ever had a child and they're sick and you don't know why they're sick, but you know why they're sick because you know your child well, that is not a signature pattern. That's you recognizing that something's wrong. And that is much better than only being able to deal with it. So if you deal with something that is adaptive in nature, that can use signatures and non-signatures, it can stop what's called the day zero attack as soon as it occurs. If the only thing that you use is signature-based, then you'll only be able to block attacks. The reason I always work with next-generation firewalls, specifically the best of the best for my clients, are, for the most part, they all cost the same, whether you use a good one or not a great one. They're pretty much accessing the same thing. So kind of keep that in the back of your mind. So there's that. So we have this. The second, so we really want it to be adaptive in nature. Keep that in the back of your mind. You said a demilitarized zone layer of firewalls would answer having multiple layers. So FB, it would. So in our demilitarized zone, we've got 2 sets of next generation firewalls. Maybe we have an IDS IPS system. Then maybe we have an access control list. Then maybe we have a security group. Then after that, in our systems, we might put host-based firewalls on them. Then we might actually disable unnecessary services on them. Then we might put a host-based firewall on the system. You're gathering it. It's layers and layers and layers. We cannot just have a system where we only protect the perimeter. We also have to protect the stuff on the inside. So it's not enough to actually stop it. We need more than that too, but it's a good start. I hope that makes sense. Okay, no more questions. So what I'm going to try and, Mark, totally, the Originals is a much better show than the Vampire DVIs. Not to deviate too much. Mark, I know you. I have deep respect for you, and I'm going to take that to heart. What's the price difference between AWS and industry DNS? We're not talking anything serious. For the most part, Dennis, you can use an industrial system, which gives you the best features and functionalities, and you can use what I call Swiss Army knife system, and the cost is pretty much the same. So, Dennis, in general, let me kind of give you a little guidance when it comes to architectures. It's less of the cost of the technology, and it's more of the value that it provides for a business. I'll give you an example. Let's say I spend $500,000 more for Palo Alto firewalls than WAF over the course of a year. Did you know the average user account that's hacked costs the business $150? So if I have 200,000 users in my database and they get compromised because I'm a target, I have to pay $150 times 100,000 users. You do the math on that one. Is it worth paying $500,000 extra for better security? Yes. What if I have a $2 billion intellectual property new design that a business might have for a new car or a new airplane, and hackers get a hold of that? Isn't $500,000 well worth protecting it? So what we have to do is we have to quantify the security risk, and then we have to deliver the right solution for it. You're not going to buy $100 million of life insurance on your cat Cindy. I might be able to do it because my cat Cindy is worth anything to me. But the point is, you're not going to buy $100 million of life insurance on your cat. But if you're a person and you had $150 million or $100 million of debt for rental properties, you probably want to protect yourself by getting $100 million of life insurance. So it's about delivering the right security. And it's more about quantifying the problem and what it's worth. If I told you that for 44% of businesses, 1 minute of downtime is $1 million lost, all of a sudden, a little more expensive firewalls are feeling like nothing because you can have 12 hours of downtime from a security hack. So it's about understanding the business needs and working with your clients. I only work with clients that lose $1 million plus a minute because with my skill, people don't come to me for less than that. I deal with clients that lose $1 million a second, and they need to be accessed. If I was dealing with a small business, like the American supermarket in my Greek village that employs 5 people, I probably wouldn't be dealing with Palo Alto firewalls. I probably wouldn't be dealing with 3 clouds. I'd stick it all on an availability zone or 2 and might use WAF and Shield and be done with it. So it's a matter of the business requirements. But businesses don't need a cloud architect for a 5-employee person. And Dennis, I'm going to go back to this. I don't know how to tell you any other way. If I put servers and spread them throughout the world, it's not a single point of failure. If I put all the servers in the same building, it's a single point of failure. AWS Route 53 is just AWS. If the Amazon network gets attacked, it's not there. If I buy servers from F5 and spread them in 500 locations, I have 499 places that can go down and still be up. If I put 2 availability zones in 3 cloud providers, I can lose 3 clouds. I can lose 2 clouds and still be up. But, I hope that answers your question. And FB, access control lists and security groups could also be in your demilitarized zone, which would be external security, or it could be in your internal system. So you're just going to need that everywhere. Here's the secret to availability. No single points of failure everywhere. 2 of everything. Just remember that.
Hey, Mike, I'd like to add into this thing.
Yes.
I think you may be thinking like I thought. F5 DNS is a thing, or is it it is a single thing that can fail, like my phone can fail?
Oh, okay. No, it's not a single thing.
Because I used to think that, that's where I would get confused, and that sounds like what.
Okay.
I could be wrong,
so,
Dennis. Let me know if I'm wrong.
And it could be so. Dennis, let's assume I buy 50 servers from Dell and put them all in the same room or the same cloud. That's a single point of failure. Now let's say I buy 50 servers from Dell and I stick 3 of them in Miami in one cloud provider, 3 of them in London in another cloud provider, and 3 of them in New Zealand in another cloud provider. New Zealand gets an earthquake. London doesn't have a problem. I hope that makes sense. So these are basically hardcore physical servers we're going to be putting, or virtual servers we're going to be putting in environments, and they're not related to each other. If it's all in AWS, it's a single point of failure if AWS goes down. But if it's across the world, we don't have these problems. So I hope that helps, because I really want to answer that. And sometimes it's good if other people think of things. I'm going to try and go to about 4:20 today instead of 4 p.m. And here's the reason I'm going to do it. I want to go about 20 minutes long today so we can finish up tomorrow by 4 or 4:15 p.m. so that all of you guys can have a free Saturday instead of spending all Saturday learning AWS. So bear with me. We're going to go about 20 minutes long today because I want to make sure you guys all get to enjoy your weekend. And you can spend the weekend if you want going back over these things. So now we're talking about AWS services. The first service I'm going to talk about again, because it's a really important one, is SQS, or Simple Queuing Service. When we talked about the databases, we talked about the means to store your information in a place so it doesn't get lost. AWS has a wonderful queue called SQS. And it's a place for you to put your messages. It ultimately will increase the availability of your systems. Because let's say you've got a web server, an app server, and a database server. Your web server is working great. Your app server is working great. You pop your messages in the queue. The database is too busy to take the message or crashes for a minute. They're stored, so they're not lost. So Simple Queue Service is there. Now, what do you do if you've got a multi-cloud environment? You leverage Apache Kafka, which has got a great queuing service too. But in a single cloud, you can use Amazon SQS. It's a pre-made queue. It's simple. It's elegant. It works great. And typically speaking, what it's going to actually look like is going to be as follows. Let's say a person places an order. It hits the web server. It goes to the application server. We can then send the message to a queue, and it can wait into the queue on the way to the database. The SES is an email, which we can set up later. We'll talk about that. So when we deal with SQS, we've got standard queues. Basically, messages come in and out as fast as they can, most scalable. Then again, we can also do what's called the FIFO queue, which is first in and first out. It's going to slow things down sometimes because sometimes messages are bigger than others, but sometimes you need it. Now, we could also create with SQS something called the dead letter queue. It comes from the mailbox. So sometimes the mailbox doesn't know where to deliver stuff, the post office, the postal service, and they drop it in a dead letter queue. And that way, if you come to the post office later and say, I want my mail, any chance you got this, they can look through a big giant box. We can also create a dead letter queue with SQS. So a message is supposed to go to the database. It doesn't, but we don't lose it. We can check the dead letter queue. It's kind of like checking your spam folder to see how many emails that you missed that were legitimate. In me, because as a CEO, I get about 150 spam messages a day. None of them are related to anything. People just trying to sell me stuff without even knowing what I need. But the point is, that's like what a dead letter queue is. Okay, so with SQS, messages are sent from the platform to the queue. They're drained from the queue when they're ready, and we move forward. When would you use a queuing system? Well, to assist with capacity planning and scalability, to make sure messages are not lost. It's phenomenal for cost optimization because by using a queue, you may need to use smaller servers. To kind of keep that in the back of your mind. We can actually look at the messages in the queue to facilitate auto-scaling for certain applications, so we can get content on demand, and so we can handle spikes in the platforms without having to scale. Now, there's another message queue. So, okay, I want you to understand, let's say you're a business and you want to order something from a cloud provider, and the service they have is almost good enough, but not really, and they decide to make something custom for you. You know what happens? They make a new feature and they call it something else. So for the people that don't want to use SQS and they don't want to use Apache Kafka, which is what most people use industrially, they can use something called Amazon Message Queue, which is going to be a fully managed open source message broker. And it uses Apache ActiveMQ and RabbitMQ. Amazon Message Queue makes it easier to operate message brokers in the cloud, so users can migrate messaging and applications without rewriting the code. It's a little different than a SQS queue, actually. Enterprise levels, customers can benefit from the most using a message queue because they don't have to re-engineer their applications to use SQS because it's more standard and it's closer to a standard queue. And again, you could use Apache Kafka. Amazon Message Queue uses pay-as-you-go pricing, meaning you pay for what you use. So what does this mean? If you don't use it a lot, it becomes much cheaper to use a pay-for-as-you-go pricing. If you use it a lot, it's going to be a lot cheaper for you to build your own message queue, like Apache Cassandra. It's kind of like taking an Uber. And I want you to think about all this with the serverless and the managed. Managed is cheap if you don't use it a lot, like an Uber. Imagine you live in New York City. You take 5 trips a week. You jump in an Uber, you pay $100 a week. It's cheap. $400 a month, and all your transportation needs are good. Now you live where I live in Florida, and you have to travel 15 miles every day of the week. Now, where I live, if I were to take Ubers 15 miles in each direction every single day, I'd be paying $1,000 a month. It'd be cheaper to buy a car. So whenever you're dealing with this pay-as-you-go, it's based on use. Don't use it a lot, go serverless, or go, pay-as-you-go pricing. Going to use it a lot, don't go serverless. It's going to cost too expensive. So you have to understand your traffic and your usage patterns before you select the technology. Most people make the error and they get really excited. I love this technology. Woohoo, this is exciting. And they pick a technology and they don't think about it till after the fact. So we talked about simple queue service. We talked about the message queue. Now let's talk about the following: the simple notification service. Amazon has a simple notification service that is a managed messaging service to deliver messages between systems and people. You can use it to decouple messages between microservice applications. You can use it to send an SMS message to people or push notifications to people. And it uses a publisher subscriber model, like an email list. You subscribe to the email list, and then you get your information. When we deal with the simple notification service, we're dealing with 2 components: publishers and subscribers. Publishers send a message to a topic, and a subscriber subscribes to the topic. Like I said, email list. I like to take things to the simplest terminology. I feel like it breaks things and makes it down. So the other thing we can do with this NSNS topic is we can send messages. I publish it to a topic. The message hits a queue, a Lambda function, an email, a HTTP push notification. These are the kind of things that we're talking about. So SNS is a high availability platform that runs by default in multiple availability zones. As long as the AWS cloud is up, it's going to work. It enables you to fan out messages, meaning you can send it to an SQSQ and a Lambda function at the same time, as I just showed you in the last graphic. SNS will allow the creation of filter policies, so you only receive notifications for what you're interested in. And SNS will encrypt your messages immediately to protect them from unauthorized access. So we're going to use SNS when we want systems alerts, when we want to fan messages to multiple systems, and we want to push a notification. For example, a realtor that's driving around the neighborhood gets a notification that the house next to them is on sale, or they just price dropped and they've got people in the car. So that's the kind of reason. Now, another topic we're going to talk about, which is totally unrelated, is something called elastic MapReduce. So when you're involved in a big data environment, you're going to be taking information from relational databases, from NoSQL databases, from data warehouses, from object storage, and you have to normalize that data. Well, what most of the world uses, they write a Python Spark script, and that normalizes the data, and they use it across multiple clouds. But if you don't want to write your own Python Spark script, you could use elastic MapReduce, and it's going to be a pre-managed service. And it's going to do the same mapping and reduction that you would normally use a Python Spark script. And Amazon MapReduce is built on open source tools like Apache Spark, Apache Hive, Apache HBase, Apache Flink, Apache Hudi, and Presto. It's an AWS branded tool. Of course, you can make your own customized based upon what you need and where you need it. But it's really about taking information from one source, massaging it and normalizing it and placing it somewhere else. That's all it's about. Key spaces, Apache Cassandra. Okay, so lots of businesses cannot use the DynamoDB or an Amazon Aurora. Many of them can. Even Netflix knew not to. So if you need, and they're only on a single cloud, but they wanted something bigger, more standard, and more robust, they wanted Apache Cassandra, especially because you can write to all nodes with Apache Cassandra. So if you want to manage your own Apache Cassandra services, great, servers, great. You can do that on all three clouds. But if you want to use Apache Cassandra and you don't feel like managing servers, and again, it's McDonald's versus Morton's, you make the choice. You want somebody else to manage it for you when you get what they give you, or you do it yourself. They've got a completely managed NoSQL database that is an open standards database, Keyspace. And it's a fully managed Apache Cassandra compatible database that allows you to run standards-based NoSQLs without worrying about the underlying technology. I'm an architect. I always worry about the underlying technology. When I don't worry about the underlying technology, it doesn't meet my needs. But, you know, if you don't want to think about it and you're looking for something more automated and more agile, this is it. And agility is worth something. So basically, you position your key spaces, and it'll provision and patch and manage your servers. And it's deployed without you thinking about the servers, the storage. And you've got two basically ways that you can set up your services, your storage performance, either on demand, meaning it just gives you what you need, or you tell it ahead of time what you need. On demand is the default choice, and you pay for what you use, reads and writes. You don't need to specify your tables, throughput capacity. It just does stuff. Now you're going to pay every time you read and write. By comparison, if it's a virtual machine, you pay it once, you own it, as many reads and writes as you want, it is yours. So again, how often am I doing it? Again, once we get into serverless, if you use it a lot, it's going to cost a lot. If you use it very little, it'll be cheaper than building your own infrastructure. So determine what your needs are. So provision is suited when you have predictable traffic and you can forecast your requirements. You specify the reads and writes. Lake formation, new service. So there's a way that you would build a data lake. If it really matters, you're going to hire a big data architect like my friend Praveen, and they're going to build you a data lake in a customized manner and make it really tuned and agile for the business. But let's say you want to create a data lake and you don't have a ton of expertise. You can use AWS Lake Formation, which is going to be a managed service that's going to make you very easily deploy a data lake. And a data lake is going to be a repository that's going to hold large volumes of unprocessed information and processed data. And the information will come from various sources. Unprocessed data is captured very quickly in its raw format. It'll be tagged with metadata. And the information will be processed. And once it's processed, it'll be assigned a tables, field, or other elements before it's stored. So you can use a pre-made data lake service. That's all lake formation really is. Now, data lakes, we create them because we're looking to create a place to put all of our analytics that later we can use machine learning and other types of environments and data visualization to see what we have. Organizations leverage data lakes to promote better business predictions, which enable them to increase their profits, create cost savings, manage proficiency. The point of any data lake is to get actionable information from the system, buying patterns, or what have you, customer patterns, so to better understand, so businesses can make better inferences. Let's talk about TimeStream. It's another AWS service. Amazon TimeStream is going to be a fully managed auto-scalar, default tolerant, cloud-native SQL relational database. Okay, we've got a lot of relational database, right? But this service specializes in storing and querying, tracking data variables that change over time, from user data, IoT, internal applications. Amazon TimeStream is capable of ingesting trillions of events over time and from various sources like sensors. CloudWatch. Now, this is simple. Here's all CloudWatch is. It's logging. That's it. Every system that you have in tech gives you a log. It spews out information. You go to a router, it gives you syslog. You go to Linux, I think it's in var/logs. Macs have logs. Windows systems have logs. Tons of it. You got thousands of devices out there, and every one of them generates logs. CloudWatch is an AWS logging service that monitors your resources. And it gives you some metrics and performance data about your systems. So you're going to use it to collect, monitor, act on information in your logs. CloudWatch is going to have some built-in default metrics like CPU utilization, disk read and write, in terms of IOPS, input and output operations per second, and network utilization, which is not a lot. CPU and disk and network. Now that's standard built in. Now you can create custom metrics if you want. Maybe you want to check your memory utilization, your API performance, or other things, and you can set up custom metrics as well. CloudWatch is going to have a notification system that will notify customers of events so they can set thresholds. And CloudWatch events can be used to trigger things like autoscaling. CPU is too high, add a new server. Kick off a Lambda function. You've been hacked, kick off a Lambda function to do something. You've been hacked. You get a notification from WAF that something's bad. You can send an SNS or a notification alert to systems administrators to come in and go fix it. Or you could use a next generation firewall. And hopefully it fixes itself. And you'll still get the notifications, and then you can come in and check it. But you'll be able to thwart the attack a lot better and a lot longer. So CloudWatch is going to give you two versions to monitor your virtual machines or your EC2 instances. Basic monitoring, which will give you data every 5 minutes. And it's at no charge. Every 5 minutes, I promise you're going to miss information. What matters when the CPU spikes to 100% and our network goes up, you're not going to catch it in 5 minutes because it's going to average it. Or you can use detail monitoring, in which case data is going to be available automatically every minute. But you're actually going to have to pay for decent logging this way. And the detail monitoring must be enabled. In your normal environment, you're going to get these logs completely every couple of seconds, and they're going to be free. But, every system is different. Amazon CloudWatch events will give you a near real-time stream of system events. You'll set up rules and events that'll match them to a function, and CloudWatch events will become aware of any operational changes as they occur. And by doing so, you can do something about them faster. CloudWatch is logging. I'm going to say it again. CloudWatch is logging. So if I talked about CloudWatch, what's the next thing we're going to talk about? CloudTrail. That's auditing. What was done? So CloudTrail is a service that will assist with auditing. It'll give you an audit log that will assist with risk management and compliance. And imagine being in healthcare or banking where you need audit logs. Well, CloudTrail is going to give that to you. So CloudTrail is a great auditing service when you need to keep track of who did what and when it happened. CloudTrail is going to be enabled when you basically set up your AWS account, and it will record events and history. CloudTrail. The event history will let you view accounts of things that have occurred, events in the last 90 days. And if you wanted to go beyond 90 days, you can take all of these logs and store it in object storage, otherwise known as an S3 bucket. Now, when you're dealing with CloudTrail, you can create two kinds of logs. A trail that is local to one region, and a one region only CloudTrail can be created that'll store your CloudWatch logs in a single bucket. This is the default option when CloudTrail is configured by the CLI or the API. Or you can create a trail that's going to apply to all regions. And this means you're going to get all the information from all your regions. It's going to give you the most comprehensive logging and auditing information. And it'll provide a record of all events inside of your organization. So let's briefly look at this. Here we go. We've got our virtual machines, our identity and access management service, a database, all sending logs, and we're storing them for future use. Okay, let's talk about a service called AWS Config. AWS Config is a service that's going to enable assessment, auditing, and evaluation of your configurations, which is good. It's going to provide an opportunity to see what changes were made and by whom. So everything's running great. Cindy the cat comes in. She logs in with my password. Cindy seems to know everything. All of a sudden, something's not working. I go into config, and I can see Cindy the cat logged in, and she deleted an IP address, and all of a sudden there's a problem. So by using config, we can actually even send a message or an SNS alert to someone that basically says, poof, something happened. And this is fantastic. So config is going to provide constant monitoring configurations, and it will check these configurations against your policies that you previously set up. If Cindy the cat goes into my systems and she makes a policy change, I'm going to get a notification about it so I configure this. So config will provide a means to assist with change management because it's going to help me figure out what's going on. And we can integrate config with CloudTrail to capture this information for long-term use. How does config work? You make a configuration change, right? And config will take note of the change. It'll record the change in a simple and consistent format. Config will then check the change against your policies, and it will notify the services and the systems administrators of anything we have to do. Visually, let's see what it looks like. Some people like our visual. We look at the configuration change. You can see config is monitoring the configuration change. And then there is S3. And you may be wondering why I talk about Cindy doing debugging and troubleshooting. Cindy is the official troubleshooting coach of the Go Cloud Careers organization. She powers off our private cloud servers with her paws. She unplugs Ethernet cables, and she does all kinds of things to get my students to try and troubleshoot and debug things. And she's cute as can be when she does it. Now, we're going to talk about CloudFront. I'm going to give all of you guys and girls and everybody out there an opportunity to do something. So I'm going to do it with you. And I want you to see, before we talk about content delivery networks, the reason why you can't use a single content delivery network, because a single content delivery network is going to be a single point of failure. So I'm going to do something with you. And I don't know what my responses are going to be, and we're going to do it together, and you're going to give me the response in the chat box. So I want you all to run this command locally on your computers. If you're on a Mac or a Linux machine, I want you to open a terminal window. If you are not on a Mac and you are on a Windows system, I want you to get to a command prompt. I think it's start run cmd. Now, Chris, I want you to share my window right now that says Michael Gibbs Mac Studio. Okay, so right over here, oh, I see what's going on. So here's my Mac, okay? I'm going to type the command, and I want you to do the same thing, NSLOOKUP. That's going to tell us the DNS name, and then I want you to type www.amazon.com. As you can see right here from this DNS lookup, I am using the CloudFront Content Distribution Network. I'm going to do this one more time. I'm still using the Content CloudFront Distribution Network. I'm going to run this a couple times, and I want you to tell me what you see. Do you see DGA3, or do you see something else? I want you to put what you find in the chat box. And I'll show you why. Have you all run the command? NSLOOKUP www.amazon.com. Put your response. Are you getting this? Or are you getting something that says Akamainet or Fastly on it or something like this? Does it look what I just put in the chat box? Or does yours look differently? Oh, no. Look at this now. So right now, you can see I have Akamai. So right now, Amazon, I know for a fact, is using CloudFront, and they're also using Akamai. How many are, so Jason Anderson using Akamai and CloudFront. Which one are you using? Paste the real answer in there. Maybe I'll get Fastly this time. Now I'm back to CloudFront. Does anybody want to tell me why I have Fastly here? Or I have Akamai and CloudFront and not just CloudFront? Any ideas? Tell me the answer to this in the chat box. Why is Jason Anderson getting Akamai? Why am I also getting Akamai? I'll tell you right now, Amazon would not trust their business to only CloudFront. They would never, ever let their business go down if CloudFront goes down. They're using multiple because it's not who's closest, because they're both at the same distance. They know that when the CloudFront content delivery network goes down, they don't want their business to be shut down. So Amazon is using their competitors along with their own systems to make sure they have high availability. They wouldn't put all their eggs in one basket. You shouldn't either. So even if the certification says CloudFront has a high availability content delivery network, AWS won't use it just for themselves. They'll use CloudFront, they'll use Akamai, they'll use Fastly. So that's the difference between real life and certification. The people that are doing the certifications won't do it either. So why do I blame Amazon? Of course not. They are a big business, and a minute of downtime will cost them millions of dollars. They cannot afford to be down. But many of you are going to have clients that are just as big as Amazon, and they can't afford to be down. And whether it's multi-cloud, multi-content delivery network, I want you to all understand that you build for your customers' business requirements. Why do you think Amazon did $1 billion deal with Microsoft to use Office 365 when they have work docs themselves? Because the reality is all of these architectures are going to take many tools. Palo Alto, Cisco, Fortinet, F5, Snowflake, Oracle, Microsoft. And architecture is an architecture where you take all the elements together. So do I think AWS CloudFront's a great content delivery network? It is incredible. It's wonderful. I just don't believe in single points of failure, single cloud, single content delivery networks, single internet service providers. Because in the end of the day, what are you building an architecture for? To make sure the business runs. So when we talk about CloudFront, it's the Amazon branded content delivery network. And content delivery networks are awesome. Fastly's got a great one. Akamai's got a great one. AWS has a great one. Cloudflare is a great one. There's a bunch of these, and businesses use multiple. But the Amazon branded one is CloudFront. And a content delivery network is two things. It is a network and it is a group of caching servers. And we're going to get into this and we'll finish on this today and then I'll answer questions. We use content delivery networks to reduce the load on our servers through caching and to prevent against denial of service attacks. Content delivery networks will add a lot to your system security because all content delivery networks will only forward legitimate requests to the server. And that's the reason why. Illegitimate requests won't be sent to the servers. Requests for the same content won't be sent back to the server, so it can really help scale. Content delivery network can promote enhanced scalability, especially if a server is temporarily down. CloudFront will dramatically improve web performance, just like all other content delivery networks, through its caching servers and through the use of its private systems. So here's the way it occurs. I'm actually going to draw it out for you. And I know I've got pre-made drawings, but I want to whiteboard it out. I want you guys to have some fun and really truly learn this. So I'm going to draw two users on my board. Bear with me for a second. I've got user one. We'll make her, here's user one. Bear with me while I create user two. Yeah, how do we do this? Let's bring user two here. We'll make user two a little smaller so we don't take up the whole screen. Okay, so we've got two users. And now we're going to make a website. One of these days, I'm going to register this domain. I use it all the time. I've got this web page, and the web page is called tuna.com. And both of these cats are highly excited about their tuna. Now, in a traditional environment, Cindy over here, this cute little girl, she goes to the website responds and sends us her data. Now, Sunny over here goes to the website and she gets her data. That's pretty simple so far. Now, they both want to go to the same page. The website answers twice. By having a content delivery network, let's say this is the CDN that's over here, and there's going to be a local, I don't know which is how. So we've got this content delivery network, and the content delivery network is also has its own private network. So normally, I remember how we talked on the first day, and I told you how the internet is basically best effort. There's no guarantees, but I can build myself my own private network and I can control it. Kind of like a turnpike where you pay to use the road versus the freeway. You know, you typically get better roads and where you pay for it. And when you build your own network, so I've got a private content delivery, a private network, which gets people's traffic off of the internet. So now, here's what happens with the content delivery network. Cindy over here says, I want to see tuna.com. I'm looking for some raw ahi tuna, some of the best tuna in the world, the kind they use to make sushi in Japan. So Cindy sends her web request, and in her web request that she sends it to the content delivery network. Here she goes. It's not stored on the CloudFront Akamai content delivery network. It gets off of the public internet. It rides the private network to tuna.com. Tuna.com answers. It sends it across the private network. It stores it in the local content delivery network, and Cindy's got her information. Now, Sunny the cat is visiting Cindy, and she's all jealous that Cindy the cat has her own iPad Pro, which she does. And I used to play little bird videos and fish videos for the cat. And now Sunny wants to go. So Sunny borrows my Mac, and she goes to the content delivery network to look at the same tuna. And the content delivery network already has it. So it sends the data back directly over to Sunny without hitting the web servers. Now, Sunny the cat invites all the local cats in the neighborhood because she's big, she's strong, she's got lots of friends. And then she shares her Mac with them. And every one of them requests tuna.com because we know most cats love tuna. And when they go to the website, every single time it gets answered by the content delivery network until the cache times out. So therefore, you can see that content delivery network enabled the web to potentially serve 1,000 web pages, the same web page, only once. So it reduced the load on the servers. So I described to you the first time what's called the cache hit and the cache miss. The first request is probably not going to be available on the content delivery network, so you'll see it goes all the way to where the asset is located. Subsequent requests for the same information get answered by the content delivery network. If all your requests are different, the content delivery network doesn't help. So content delivery networks are wonderful. CloudFront is an amazing, exceptionally good content delivery network. But if it matters, use more than one. The expression in high availability is 2 is 1 and 1 is none. So CloudFront will enhance your scalability. It will cache and reduce the load off of your systems. And it is very, very helpful. CloudFront will integrate with plenty of AWS services, just like Akamai or any other content delivery. Whether you want to integrate it with your load balancers, whether you want to integrate it with your virtual machines or your object storage, or if you've got a static website, it's going to basically make your website scale, and it's going to do so in a dramatic fashion. Now, with static content, it's pretty simple. You would just set up CloudFront in front of an S3 bucket, but you might have some dynamic content and static content, which is pretty normal in the web environment, where CloudFront, where you'd put your dynamic content on a virtual machine, or virtual machines behind a load balancer, and you put your static content in object storage, and that will also help with website scalability. So, that's the way we're basically dealing with CloudFront. There are some key concepts in CloudFront. We're going to talk about distributions, origins, and cache control. A distribution is when you set up CloudFront, you set up a distribution. And that distribution was specified by that really ugly looking name that I showed you that I popped into the chat box. And that name becomes the URL for your website. But, going back, I'll pop that again. This was the, so I gave you this, and I just popped it back in the chat box. When I did an NS lookup to look up the URL, I got a D3AG4HUKKH62YN.cloudfront.com or .net. Now, I don't know about any of you. Can any of you guys remember that? No. So typically speaking, when you leverage a content delivery network, any of them, whether it be Akamai or whether it be Fastly, whether it be Cloudflare, whether it be CloudFront, you're going to get that ugly looking URL. And you want it to say Amazon, not Delta 3 Alpha Golf 4 Hotel Uniform Kilo Kilo Hotel 6 2 Yankee November .cloudfront.net. So you're going to create a CNAME record that's going to map Amazon.com to that ridiculous long name that I just gave you. And that way it becomes a simple URL. Now, where's the CloudFront origin? That's where your stuff is, whether it be your S3 bucket or your virtual machine EC2 instances. And let's talk about the CloudFront cache control. As we previously discussed, CloudFront is going to cache your stuff. That's how it works. But it needs to be stored. And we can have it cached for 24 hours, which is a default. But if we cache an information to the tuna.com webpage, and all of a sudden my systems administrator puts some brand new tuna on tuna.com, Cindy, Sunny, and her friends aren't going to see it for 24 hours. But the cache will hold that information, so for 24 hours, those web servers won't have to respond for that same information. We change the cache to an hour, the cache will time out after an hour, and each hour it'll get reloaded again. More work on your web servers, but fresher web service. What's the right decision? What does the business need? How often does the business change your content? Are you getting the concept now that everything you need to think about, and it could take you 6 months of investigations long before you can even think about designing an architecture in a big business? Sometimes you can get the information in a day. Sometimes it takes weeks or months to collect the information, long before you can get to the solution. So I hope that that kind of makes sense. Okay, so keep that. And anybody that's ever worked with caching in the past, in any time for anything, also knows that sometimes You store information in the cache, it gets corrupted and everything gets icky. So what do you do with then? You clear the cache. So you're going to set it up by setting up your web servers, put your content on them. You create your content delivery network or CloudFront distribution. AWS will assign a domain name. You'll create your CNAME record, and AWS is going to go provision and configure all the edge locations for you. And really what it's going to look like is as follows. You know, you've got your regions, you've got your data centers called availability nodes, and your edge locations, which are where those CloudFronts are things. Let's see if there's any more on CloudFront. So CloudFront will increase your website performance. And guess what? A content delivery network can also improve your website availability. So I want you to think about this. Web server crashes, but tuna.com is still cached on the web server. Sonny the cat can still peruse tuna.com, even if the server's down, if it's cached and stored there. So it'll actually enhance availability. It'll improve routing efficiency because it's going to get your information off of the public internet, and it will promote persistent connections. CloudFront will also integrate with Web Application Firewall. You can pop it on CloudFront. CloudFront has a DDoS protection. You can pop Shield there, and it will help reduce DDoS attacks by only sending legitimate requests. Now, one other thing that was quite good. Remember I told you how encryption of SSL and TLS protocols? Well, CloudFront can enforce these protocols for you. It can integrate with the certificate manager for an SSL certificate, and it can support server name identification. We can also use CloudFront for private content. So we have public websites, which is a website like tuna.com, which I don't know if it's a real website or not. I just made it up, so don't take it down. I mean, or don't even. Maybe I'll look for it later to see if it actually exists. If not, I'll find a new website. But you know, in my hypothetical tuna website, what if it had subscribers? And if you're a VIP and you subscribe, you get access to members-only content. Well, you can also do that for paid website subscribers and private applications. And what we would have to do to make that work is we would set up an origin identity and use signed URLs and signed cookies. Okay, well, I think I'm going to stop the content there, see if anybody has questions for up to 10 minutes. I can't go beyond that because I will get murdered by management. I was told they provided things that I had to do today, but I really want to give you as much as possible. So I'll give you 10 minutes of questions, if any questions pop in. Before we get to the questions, join us on Monday on the How to Get Your First Cloud Architect Job webinar. There is a big difference between certified and hireable, and I want you to know the difference. I want you to have every skill so you can get an incredible job. So that'll be on Monday night. I also have a completely free ebook we wrote for you on how to get your first cloud architect job. If a static website is hosted on S3 with Route 53 and CloudFront, where do you define redirection rule, like rewrite rule? And I'm not actually sure what you mean by that, Augustus. I'm not actually a person that implements these things because I'm an architect. I design them. So I would read the AWS documentation on that. It's a good question, though. I will get to, and I think Matthew Robinson had one regarding certification. So Matthew Robinson asked, as far as the certification test, will the application and services be compared for what to use them for and when? In most cases, it's just going to be the name of the service and basic questions about the service. It doesn't have a lot to do with when you use these services. So a little bit, yes, but honestly, it's about a name of a service and how could the service be configured and what it looks like. it's a very basic test, but I'm not really sure what it's actually testing. In that it's not testing your architectural skills. It's not testing your engineering skills. I would almost consider the associate test a little more than a vocabulary test. So, for example, what is a way that you could reduce the load on? It might say something like, CloudFront is A, a content delivery network, B, a content delivery network with encryption, C, a website for services about meteorology. It'll be something like that. They're going to be relatively simple on the associate, but much more of a vocabulary test than an actual knowledge test. I think that's the last one, right, Chris?
I believe it is.
Okay, well, I hope you guys all had a good time. I will be back tomorrow. We will finish the rest of this. And there's one question from JPS. Does TOGAF certification really help? If you already know how to be an architect, TOGAF certification will be incredibly beneficial for you. It will give you a methodology. So it'll say, start with the architecture vision, then focus on the business architecture, then focus on the data architecture, then focus on the technology architecture. So if you're already an architect, TOGAF is great. If you don't know architecture, TOGAF won't teach you architecture. Does it make the professional more of a practical test? Again, the practical test is more of a vocabulary test. None of these AWS exams really relate to anything related to an architecture career. Nothing. So I'd love to say it's practical, but it's not. Is this sufficient to practice the SA professional? If you were to use a practice test and you got used to the way they answer questions, absolutely. But I'd say this only covers 80% of the professional, and I would get really careful about how I would answer these questions. The questions are written very complicated, even though the content is very simpler. And I think Wesley, thank you, Mike. You're really helping me understand a lot of things and a better way to take the exam next week and get a pass. Wesley, I'm so happy. That's my whole goal. Arslan, you're more than welcome. And we're not going to do an after-hours session today. We did a couple. I unfortunately must rest my voice. I have chronic vocal cord problems, and today we can't do one. But I think we're going to finish up early tomorrow, so we'll have time for some questions. Whether what format we do it, we'll figure it out. And yeah, it's always an honor.
That's big bad me making Mike take care of himself.
And the reason Chris does this is last year I couldn't speak to my wife for well over 2 months. I literally had to text her, sitting in the same room with her, because I developed lesions and nodules on my vocal cords from speaking so much, because I really love going out there and helping, and I speak a lot. So we're going to do as much of it as we can for free. So I hope to see all of you on Monday. I really want to help get you guys hired. And at the same time, I will look forward to seeing you back tomorrow. And please download the free book on how to become a cloud architect. Please download the free ebook on how to pass the associate and professional exam. I'm going to give you everything we can. So take care, everyone, and have a wonderful day.